All right, let's start. Welcome to the last of the help sessions. And you have your exam tomorrow, which will be fun. For anyone that hasn't joined before, there's a chat on the YouTube. Please use it. It makes it more bearable than talking to yourself. I don't really care what you say, as long as you say stuff. Obviously, if you participate, you get the most out of it, and it makes it easier for me. I'm generally happy to stay as long as you like, as long as people are participating. I've got some stuff prepared, but any questions you have, you can raise them. Bitwise stuff, we spent about 2 to 3 hours on yesterday. So if you've got bitwise questions, you may want to refer to that instead, unless there's something that you didn't understand from yesterday's session. Further from that, let's start with some questions, I think. The other thing is that I'm going to have a little bit of a wrap up with some other stuff that's not going to be an exam, but definitely helps you understand what C is and logic and stuff like that, because C by itself is a language. You can learn English, but you can write a very horrible book. You can learn C and not be able to program anything very well. So the logic side of things is really important, and that's why on the exam we have the flow diagram and the question where you need to answer the, you need to write code, and that's purely because we need to test your logic. Logic is not something that is purely coding, it's everything in your life, really. And it can be very simple, like knowing that you need to eat to survive, versus logic of deciding to use a struct or use a bunch of arrays for memory management. The logic side of things, you may be able to get a solution, but is it a good solution? And this is not purely programming. So even if you aren't going to use much programming in your future, it's still very important, that logic side of things. And you'll see how important it is as you progress with your degrees or masters. All right, so if you can hear me, just say that you can hear me. Put something in the chat, anything. Keep going. Make this a little bigger. What have we got here? All right, so what I thought I would start with is some questions from a previous exam. This is 2006, so quite a few years ago. Now, you should all be aware that the exam is going to be in a similar format. But these questions are still very useful. And this question is actually quite useful because, and there's a big hint there, we did tell you that there is going to be one thing you're given in the exam, which is the precedence table. So you don't need to memorize the precedence table, but you do need to understand how to use it. So let me grab the precedence table as well. So that was in the handout that I gave in Lab 1, that reference sheet. So it may be in a slightly different format, but you do need to know how to use this. So I've got this question up here. Have a quick go through it while I copy this across. So put your answers in the chat. This question shouldn't take more than a minute or two. Grab the precedence table and show why this is really important. And I might flip this around a bit to show you the importance. So put your chat answers in the chat. If you don't know, say don't know. So we got a 5, 4, and a 0. Any other answers? 5, 4, and 0. So someone asked about if we stuff up the exam, we get a redeemer. Is that true? No, that's not true. You may get a reset, but that depends on a whole heap of factors. So, firstly, if you get like 49 or 48, that will be the first factor out of 50. Your mark before the exam will be another factor. Your participation throughout the subject will be another factor, which we can look at LMS and see have you read all the notes as we were going and so on. And then there's some other factors like your other students, did they pass and fail? Were you way below average, etc. So you may get a reset, you may not get a reset, do not count on it. Okay, we've got a lot of 5, 4 zeros. That's good. That's really good. So this would be yeah, we got another 5, 4 0. Beautiful. So considering we've got an exam tomorrow, that would be really good if these were all right, but they're all wrong. Okay. So let's get the precedence table up. And the one in the exam will look similar to that. Okay. We got a 2, 4, 0, which is also wrong. Okay. So we have A is 3, B is 4, and C is 0. So we've got these three values here, A, B, and C. And we have 3, 4, and 0. Okay. Now, is A equal to 10? No, it's definitely not. Okay. We then get to this else if. Now, we have a bunch of stuff here. So we have two brackets, okay? And brackets take the highest priority, okay? So we have these brackets, and we have to execute these in order. From the left. So we first check, is B equal to 4? Yes, it is. So we get a 1 here. And we also need to do this, B equals 2. Now this is an assignment. Okay. Now, even though it's down here on the precedence table, okay, the brackets are before the ands. So it just follows similar to BODMAS, except this is just a larger BODMAS. So this isn't a condition, this is actually assignment. So B becomes 2. So this here now becomes the value 2. We have a conditional AND. So we looked at bitwise AND yesterday, and now we're going to look at conditional ANDs. So I'll do a similar table. So we have AND, and we have OR, and we have a couple of cases. We have 0 and 0. We have not 0 and 0. We have 0 and not 0, and we have not 0 and not 0. Now, not 0 is any number other than 0. So it could be 1, it could be -1, it could be 10, it could be 43, it could be 86, or so on. Any number. And so this gives us a 0, and this gives us a, oops, that's an XOR, a normal OR. So if both are 0, both not true, then we get a 0 out. If one of them's not a 0 and the other one's a 0, we get a 0. So they both have to not be 0 to get a 1. So if we have a look at this expression here, we've got a 1 and a 2. Now this is conditional, not bitwise. Okay? So a 1 and 2 result in a 1. A 1 is true, hence C becomes 2. Multiple layers, wrong layer. So we don't go to this else because we've already been to this else if, and so we print the answer. We get 322. Okay. Does that make sense? So let's play around with this a little bit and make it a little bit more interesting. So I'll just get the question back up. I'll make another copy of it. Knowing what we know now. Let's get rid of that. Get rid of that. Get rid of that. So I'm going to keep the same question, and I'm just going to change some things. So what would the answer be now? Beautiful. So this time, A gets set to 10 at the start. Okay? So A is 10. So this evaluates down to 10. 10 is not 0, so then we go into here. And B gets stored into A, so now we have a 4. We've done this if, so we don't need to do these, and we get 440. Okay? We don't evaluate this else if, so there's no 2 there, because we've done the if, and so it's going to go down here. So I'm going to make this a little bit harder and test your bitwise operations that we did yesterday. And I'm going to change this to this. Now what is the answer? I'll give you a little bit more time on this one. While I try and find another question. That's a good question. That's a good question. So someone asked a really good question. We'll do this one first and then we'll ask that if A was equal to 0. Okay, so we're going to have a look at this one and we'll just see how a conditional and a logical and do change everything. And same with the equals operator on the assignment. We're seeing, yeah, this will still compile. Perfectly fine. So we have A, which is 3, we have B, which is 4, and we have C, which is 0. A is not equal to 10, so we can ignore that. We get to this else if. We have B, is B equal to 4? So I might actually just pull this out a bit so that I can do it step by step. So is B equal to 4? Yes. Yes, it is. So we get a 1. We then need to do B becomes 2, so we get a 2, and this changes to 2. Now, we can quickly convert these to binary numbers. So 0, 0, 1, 0, 0, 0, 1, 0. And we can perform an AND between these, like we did yesterday. And 0 is 0, 0 and 1 is 0, and the rest are going to be zeros. Okay? So this evaluates to 0. Okay? So this is now 0. So then we get to the else case. Okay? And A becomes 5. So we get 520. Okay. Does that make sense? Just say yes, no, maybe. All right, so I'm going to change this question another time. And I'm going to change this to a 3. Now, I'm pretty sure this was mentioned in the lectures. but if not, that's okay. We can go through it quickly now. What is the result here? And this one's actually a bit more tricky. Sorry, just something. Okay, what do we get? 520, 520. Okay, so the answer is actually 540. Now, this is because of something called short circuit evaluation. And I'm pretty sure this should have been in the lectures. So this is something C does to speed things up. So we get to this stage here, and we have this B equals 3, and B is assigned 2. Now, this is evaluated first to 0. Okay? Now, C already knows that this condition is going to evaluate to 0, because if one of these is 0, I lost my table, I don't know where I put it, then the result is going to be 0. So it doesn't bother evaluating the right-hand side if the left-hand side is 0. And this is called short circuit evaluation. So it will just ignore this side. Does that make sense? So it already knows that this is going to come out as 0, so it doesn't bother checking this. Okay. 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 Let's go on to another question. I don't know why I wrote all that out. Some questions. That's a good question. Okay, we have another conditional question. A nice one, a simple one. The previous change. Which previous change? This one right here is, the previous change here, I think it was 520. Someone can confirm that. I can't remember. Okay. Oh, with the single and, yeah, it was. It was 520. Okay. So I'll give you a minute to solve this. Another question. Do this. I'll give you a couple of minutes. Keywords around as well. Have your answers in there. And if you don't know, just say I don't know. Should we do this? There we go. So check your answers in. As I said, if you don't know, say don't know. Okay. So this is where you need to be careful. I think I noticed a lot of students were trying to learn the subject of the labs, the lectures. Don't forget the exam is about the lectures, not the labs in most cases. So here we have the ternary operator. So question mark. So basically the ternary operator is kind of different than an if statement in the fact that it actually returns a value. So let's do a quick example. So we can write something like this. Int x, if 4 is less than 8, then x will take the value 3, else it will take the value 2. Okay, so this is the value if true, this is the value if false. Okay, so in this case, what does value x equal, or x become? Cool. So x becomes 3. If this evaluated the other way, so if I change this around, then x would become 2. Okay. Now, we don't need to store this result. We could put it in an if statement. Now, In both of these cases, this is going to be true. Right? So let's have a look back at this question. I think I accidentally erased it a little bit. Paste it again. Let's get rid of that mess. So we have A is 0 and B is 10. We have if bracket, 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 A less than B, question mark, B, A plus 1, which is the ternary operator, over 2. So the first thing that's evaluated is this A less than B. Is A less than B? Yes. So we get a 1. Okay? So now we need to evaluate this. Is this true or false? Now I just want to check something. So this is true, so we get a B, so we get 10. Now, these aren't bracketed, so we still have the plus 1. So is 11 greater than 2? Yes. So now we can take this. Wait, it's not plus 1. There's higher precedence, so that will add first. Sorry. Ternary operator happens after. So I'll go back and I'll show you what I mean. That's my fault. So it's actually 10 is greater than 2. The reason being is because plus has a higher precedence, so this will actually be calculated first. So we actually get 1 here. We get 10, question mark 1. And then we calculate it. It's greater than 2. And that's in brackets. So we get 10 is greater than 2. So the result will be A equals 0, B equals 10. Okay. That's a little bit of a tricky question because of this plus 1. But with your precedence table, you pick that up fairly quickly. It's not expected that you memorize it. Generally, you try and avoid them kind of things so that you wouldn't do that. And you use brackets. I would definitely not. You shouldn't need. So my general rule is try and write your code such that you don't need the precedence table. So if you put a brackets around here, you don't need the precedence table. Unless you're doing assembler or something. All right, have a look at another one. Difficult. We can skip that one. I'm sure I know that. Oh, beautiful. Okay, so I got a really good one here. And this one involves the string functions. I mentioned this yesterday. There's a couple of string functions you should definitely know. These were string copy, string length, string compare, and string cat. So I'll give you this one. I'll give you a couple of minutes to solve that. So have a go at that. Let's sort out. These keyboards. How we go with that one? Answers. Okay, so put your answers down once you've got them. I'll give you a couple minutes. A couple more minutes. That's actually a good question. Oh my God. That's so much shit. Peter. We're kind of getting similar answers. Let everyone else answer. If you don't know, you don't know. Just give a guess. What would you write on an exam? So keep writing your answers. Let's set this up. This is the best looking thing in the world. So that's name one. And we have name two, which is 6. 3, 4, 6, which is 8, 8, are. I. Okay. So I've created name1, which is currently just 30 bytes in memory. We have name2, which is Peter, which is 6 characters because we've got the null terminator. The null terminator is 0 as a number or as a character. It's /0. But I'll just write it as a number. Then we have this for loop, so we set I to 0. Is 0 less than 10? Yes, it is. So name1 I becomes 0. Then we go around and we know what a for loop does. So this will go from 0 to 9. So 0, 1, 2, 3, 4, 5. Oh, whoops. Why am I writing 0? It should be P. Sorry. P, 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 P. So that should be from 0 to 9. We've filled this with P's. Okay. And if we know what a for loop's doing, we should be able to pick that up fairly easily. Then we do a string copy. Okay. So we copy name2 into name1. Okay. But we're doing it name1 plus 1. Now remember, name1 is a pointer because it's an array. And so plus 1 will go up 1 character. So we're currently pointing here. And it's going to copy name2 into there. So we copy in the string. So we get P, E, T, E, R. Okay. Now, at this point, we also need to copy one other thing across. And that is the null terminator. So at this point, right here, we get this null terminator because we've copied the full name2, which includes a null terminator. So I can get rid of those quotes. We've got a null terminator there. Now this means that if we try and print name1 at this stage, before we get to the string cat, it's going to print P, P, E, T, R, E, R, and then stop. Because the null terminator tells us where the string ends, even if there's characters after it. Okay, and that's why we need a null terminator at the end, so we don't just keep reading memory. All right. Then we apply a string cat. So a string cat will add name2 to the end of name1. Now, the end of name1 is currently here. It doesn't care about these P's here because the first null terminator is here. Okay, so this is currently the end of the string, not here. Okay? Because the null terminator tells us where the string ends. So we now, once again, we concatenate Peter to the end. So we get P, E, T, E, R, null terminator. Now this is the new end of our string. So then we print out our string. So name1 equals P, E, T, no, oops, P, P, E, T, R, P, E, T, R. And that would be the answer. Okay, does that make sense? So this null terminator character, which we can see If I get up the ASCII table. It's a null terminating character right at the start, and it's always the value is 0. Right? And that tells us where the string ends. So something dangerous, and maybe I can show you an example. So I'll just show you an example. I can show you a real example too if you like. Okay, let's say this is memory, and I'm just going to say this one's a legal memory. And then I'm just going to put random values. So, actually, I'm going to put random. I'll represent it as ASCII. A, T, J, exclamation mark, new line, H. It's only a 6-mark question. It shouldn't be too difficult. T, V, W. So I'm just making up random things here. Memory is usually not this nice. So I'm going to put 0 here, null terminator. T, V. And what I'm going to do is go car A 5. And I'm going to not write this in string format, purposely so that I don't include the null terminator. Okay. And this, let's say, goes here in memory. Okay. So we've got car A 5 hello, and what it'll actually print, if I go printf %s A, is it's going to print hey, hello I L, because there's that 0 here. Okay. Now, if this was another character, let's say it was a P, it would print P, T, V, A, T, J, and then it will segfault because it will reach invalid memory. Let me see if I can do something quickly. Now, you may often get lucky that there is a bit of memory there that is a 0, but you can't rely on that, and that is really dangerous to rely on. But, oops, put that there, run that. So even if this is 6, I still haven't got the null terminator because I haven't specified it as a string. I could specify a null terminator at the end if I made it 6, but I still have to do that. So I could fix this by changing this to 6 and then changing the last character to a 0. Okay. Or I could just write hello in strings, because these quotes here automatically include the null terminator. Can we make that bigger? This. Size 24. Okay. So there you go. So you've got hello, and then a random P, an @ symbol, some other random symbol, T, a square, and then it reaches a 0, luckily. And if I run that again, that's where we get a nice little result. No, they use the same bit of memory. Yeah, use the same bit of memory. Right? Does that make sense? So with these double quotes, we automatically include this null terminator. And this tells us where the string ends. Because it's only a pointer to the start. There's nothing telling us how long this string is. So all that we see is this, really, and it just keeps going until it reaches it. It's a trust thing. All right. Let's go up to this corner. Okay, so this is a slightly higher marked question, but I think it's actually a really good question. Plus. So I want you to attempt this. This is 8 marks, so it should take about 8 minutes or so. So I'm going to have a quick break while you do that. I'll be back in 5. So we've been going for an hour now. We should go with heavy now. Move some stuff around. Cool. Alright, so we all got kind of varying answers. You all seem to get the mod operator quite well. So let's go through this quickly. So X is 18, Y is 9. We can already see that C is irrelevant. We don't even need C, so we'll just ignore it. We have pointer 1, which points to X. And we have pointer 2, which points to Y. We then get to this equation here. So we have dereference pointer 2, so we have 9 is greater than dereference pointer 1, which is 18, mod 10. Now, mod, and this really annoys people from mathematics, so this is, programmers refer this to this operator as the mod operator. It stands for modulo, not modulus. Modulus is the absolute value. Modulo is the remainder. So 18 divided by 10 gives 8 as the remainder. Okay. So is 8 less than 9? Yes. So now we do a printing function. So we have X, which is 18, plus dereference pointer 1, plus 18, which gives us 36. Okay, so we've printed to the screen already 36, and I think most people here got that part right. From what I can see, yeah. Cool. We then go, we don't need to do the else, so we get to this last part. So now we have dereference pointer 1, so 18 mod 3. Now, does 3 divide it into 18 perfectly? Yes. So the remainder is going to be 0. So we get this 0 here. We then get to the last stage. So we have dereference pointer 2, which is 9. We have this plus plus, but this is post increment. So we print a 9, and then Y changes to 10. So the answer is 3609. Okay, it is not 10. So I'm just going to do a quick example with post and pre. So let's say int x is 10. No, it's not going to be recurring because it's how many remainders of this. So 1 over 3 is going to be 1 remainder. So for example, 1 mod 3 is 1. It is not 0.3333. We're not talking about the decimal part, we're talking about the remainder. Okay, so just a quick example. Let's go to y becomes x plus. Let's make another variable. Z is plus x. X, y, z. I probably should put some format specifiers. Okay, so let's quickly go through this example. So here we have a post increment. So the plus plus is after. And here we have a pre-increment. So x is 10 to start off with. Then we have y becomes x. And then x post increments. So y becomes 10, and then after the operation, we have 11. Yes, if it was plus plus bracket dereference pointer 2, then yes, it would be 10. Okay. We then get here, and we go in z becomes plus plus x. So this pre-increments. So it increments x one time, so we get 12, and then stores the result. So we get 12, 10, 12. Does that make sense? Why is that being stupid? So we can have op plus plus, op plus plus, op minus minus, minus minus op. Okay, go away. So these ones go away. A post, pink is killing me. Post, and these ones are pre. So after the operation, we will increment. Okay. So if it's before, then you use it in the equation. So these ones are used in the expression. And op is changed. This is not used in the expression. So the old value is used. And op is changed after it's evaluated. Okay. Does that make sense? It is a little bit confusing, but that's brilliant. Post increment operators. Yes, so if it was a pre-operator, then it would print out the value. So we could do something like this. Um, no, we can't because it's illegal. So I'm going to go int x is 10, int y is 10. I'm going to go printf. Now you can't have a pre and you can't have multiple increments in the same expression. It's illegal. But we can do something like this: %d, %d, and then I'm going to go x plus plus, and I'm going to go plus plus y, and then I'm going to go printf %d, %d, x, and y. Okay. So this printf is going to print 10, 11. The reason being is that x is incremented after the operation. So it'll use that 10 and then x will become 11. Where in this case, it's a pre, so pre the operation. So we get y is incremented by 1, so y becomes 11, and we use that in the expression. So at the second line, we'll just print 11 and 11. So we've got a nice pointer example here. I've got another example there. So have a go at that one. Let's see. It's not great, though. X, Y, Z. It's 12, 10, 12. X plus plus Z plus plus Z, yeah, it's 10, it's 12, 10, 12, not 10, 10, 11. Because X still gets incremented. So X changes. I'm not sure what you're going on about now. That's a question. That's a good question. Right, I'm just trying to find another question. I'll give it a chance for everyone to put their answers in. Well, I can find another question for the next one. That's killing all of these questions quite easily. Reasonable one for the previous exams. Getting conflicting answers. Cool. That one is multiple answers. What would you write on an exam? I'm an educated guess. Do we get marks for working? It depends which questions. For the multiple choice, no. For actually, for the multiple choice, no. For the output questions, no. No, you don't get really. No, you don't get questions for your working. I mean, marks for your working. But obviously, if it's being reviewed because you got 49, you probably want to show your work on that. Okay, well, why don't you think this will compile? No. For questions like this, you need the right answer. Or for a question like this, it might be is num one, num correct, is num two correct, is pointer correct, is pointer two correct. And then it might be some formatting things like half a mark, did they use commas, stuff like that. Yeah, for a question like that, this, or if the answer came out as something that was one mistake, that might be a mark off or something. Yes, you can definitely get part marks. Where are we assigning the pointer to the pointer? No, we're not. Okay, let's go through this. This will compile. There's nothing wrong with it. Let's have a look. So we've got two variables. We've got num, which is 10, We've got num2, which is 20. We've got a pointer, which is called PTR. And we've got double pointer, called PTR2. They're all ints, so I don't really care about their type. Pointer 2 points at pointer, which is all good. And pointer points at num, which is all good. We then dereference our pointer, so we get to this value here, and we increment it. Now, there's nothing else happening on this upper line, so pre or post, it doesn't make a difference. So we end up with 11. Okay. We then get to this next line, which changes PTR to point at num2. Line that up quite nicely. And now we get here. So let's calculate this first. So dereference PTR, so we get 20. We add num to that. So we get 31. Sorry. And we dereference this twice to where we store it. So it's on the left-hand side, so this is where we store it. So we dereference it once, dereference it twice, and we store 31 here. So num is 11, num2 is 31, and dereferencing PTR gives us a 31, and dereferencing PTR2 twice also gives us a 31. So the answer is 11, 31, 31, 31. Now, one other thing that you should think about is that there is only 2 variables declared in this. So you can do a quick check with little things. So looking at my memory here, I can see that there's only 2 variables that hold numbers that are declared. And I'm printing out numbers here. So if you get 3 different numbers here, unless there's an equation here, does that make sense? So just something to think about. So I found another fun question. What was it? This one? What was this one? Oh, yeah, I think it was this one. Yeah, this is a good question. I like this. Would I consider these questions to be hard? I'd consider them to be average. They're not extremely easy, they're not extremely hard. These are on older exams, and the subject definitely has become a lot easier. So your questions may be slightly easier for some of them. Yeah. But this is fairly old exams, and yeah, the exam questions were harder, but these are rather average. They're not extremely hard or extremely easy. You might find that your exam is slightly easier, but there might be a couple of hard ones just to differentiate the top students. But with any questions, they're all there to help you. But yeah, your exam is definitely easier than in the past, and the subjects are a lot easier than it was in the past. All right, so I have this question here, which is a nice question. So I haven't got that. I'll give you a couple of minutes. All right, so I haven't got that. And we'll see how we go. If you're understanding these questions, you understand language fairly well for most of these. Obviously, these are testing logic, but these are testing your language skills. And these are quite good questions to check to understand the language, because they were written in a way that includes a bunch of stuff in single questions. But yeah, the exam questions are kind of, well, these kind of questions are similar to the quiz. And this year's quiz was average. It wasn't extremely hard, it wasn't extremely easy. Read the notes, you can pretty much get marks. All right. So have a go, put your answers on, and we'll go through it in a minute. I'm just going to grab a drink. Oh, there's the other one. All right, how do we give? Okay, we've got some universities, we've got some U's, we've got some. Okay, let's go through it. I don't think anyone got the right answer. I think. Double check. All right, so I've got a string. 1, 2, 3, 4. Okay, I'm gonna make it bigger. So it's a bit easier for me. U M I V E R S I T Y L. And these are all characters. All right, so we have this university, and we have this 22. Shut that pointer there. We have this 22, which is just a single car pointer. We also have num, which is an int. I'll just make a note of that. And then we have pointer 2 becomes, my screen just went blank. We have pointer 2 becomes pointer 1 plus 2. So pointer 1 is currently here, plus 1 plus 2 is here. So we are pointing here. Okay. So now we've got this for loop. So num starts off as 0. Is 0 less than 2? Yes, it is. So we have pointer 1 plus num. So pointer 1 is here, plus num, which is 0. So it's still pointing at this u. And this gets stored at pointer 2 plus num. So pointer 2 is here, plus 0 is still here. And so we are going to store this u here. So grab another color to show that it's changed. Okay. Are we all good up to this point? We then increment num because we're using a for loop. So num now has a 1 in it. Is 1 less than 2? Yes, it is. So pointer 1 plus num. So pointer 1 plus num is going to be plus 1. So it's now looking at here. So we've got dereference, so we've got n. And n is going to be stored at pointer 2 plus 1, which is here. So we're going to store an n here. Okay. We then increment num again. So we get 2. Is 2 less than 2? No, it's equal. So we end that for loop. And now we do the printing. So pointer 1 is printing a string. So we get un, ersity. Pointer 2 is still currently pointing here. We've got a comma and then a space. Okay. So we are printing U-N-E-R-S-I-T-Y. We then have a comma and a space. We are printing pointer 1 dereferenced, and that's okay because this is a character. So we print a U, comma, a space, and then we print pointer 2 dereferenced, and we get another U. And so that is the answer. That's a pretty good one. Let's find another good one. Whoa. I can't even find one. No. Oh, this is good. This one has structs. Touch structure. Okay, this is quite a good one as well. Let's do this. Okay. So I'll give you a couple of minutes to do that one. See how you do. This one has a struct, so we'll get going with that. Yeah, you do need to know how to do structs as well. So there we go. See what you get and check your answer in the chat. Unless you have a question. Yes. One thing you might notice also is that the styles are very different in this exam versus the style between the labs and also the practice exam and your actual exam when you do it. Every programmer has slightly different style. Even if they're following a standard, you can still see their style come out. Same with English and stuff. Everyone has this slight twist. Even, well, all the books would be the same. Okay, so we're getting some answers in, which is good. Okay, so we've got quite a few answers, and a couple of people have done something wrong. Why am I grayscale? All right, so we're all very close, but as before, there's always that one mistake that seems to grab everyone. All right, so we create a struct student, which has a name and an age. So I'm going to make this like this. So we've got yes, struct student T, and inside that we have, I'm going to put age here just to make it easier for me, which is an int, and then we have a name, which is a car, and then there's 50 across. Okay, we don't need all 50, so that's quite a good thing, because that would be a pain otherwise. So that's what our struct looks like, and then I've got another variable, which is I. Just do that to make it a bit clearer. So I equals 0. 0 is less than 5, so it's okay. If I is less than 2, so 0 is less than 2, then s dot name 0. So s dot name 0, which is this one, becomes an A. We've done the if, so we can skip the else. Now, you'll notice that there's no braces there. As long as the following thing is on one line, you don't need the braces. But I always recommend including the braces anyway. It doesn't hurt, and it doesn't affect efficiency. It just makes it more readable. So we increment I, and this becomes 1. 1 is less than 5. Is 1 less than 2? Yes. So we get a there, because name 1 should be in this index. So we keep going, and I becomes 2. 2 is less than 5. 2 is not less than 2 though. So we get a C in the tooth spot. 2, 3, 4, 5, 6, 7, so on. We go back up. I gets incremented to 3. 3 is less than 5. So 3 is definitely not less than 2. So we go to the else. We get a C. Go back up. I becomes 4. 4 is less than 5. 4 is not less than 2. So we put a C. We go back up. I is incremented to 5. Okay. Do not forget this part happens as well. Is 5 less than 5? No. So then we get here. So we have a bunch of characters in here. And we get S name 5 becomes 0. So this is 5. And we have a 0 here. Now, this 0 is a number. Okay, it's not a character. So if it was this, it would be a character. But because it's not a character, it's 0, meaning it's the null terminator if we look at the ASCII table. Okay, the character for null terminator is /0 as well, if you want to write it that way. And then age becomes 5. So we now print the name, which is S, so we get AACCC. Remember, the null terminator tells us where to stop printing, okay, or else it'll just keep printing random garbage. And then we have our age, which is 5. Okay, does that make sense? Say yes if it does, no if it doesn't, cry, sadness, whatever. The 0 is the null terminator. Yes. ASCII table. Copy. That's not the ASCII table. Oh, yeah. ASCII table. Copy. Paste. There we go. So we can see here that 0, if I just put a 0 in, that's the null terminating character. Okay. So the 0 is the null terminator. Versus 0, the character, which is 48 in decimal. Okay. And that's why we can't print. Cool, cool, cool. Question's kind of boring. Wow. Okay, I just found an awesome question. Other question. What's the other question? That's so easy here. Yeah. Thank you. Here's a really nice looking question. How about that one? I don't know why everything is Peter. There's old exams. It's not the lecturer's name. brackets, which is nice. This one shouldn't take too long. Sure, we can do box and pointer diagrams. Sure. The gen programs are just generator. I just wrote a program to generate them. I was going to rewrite that program. It's not the greatest program. It does produce some bad code, but it generates good enough code for you guys to practice. But it's C code. It's quite nice. It's C code that's producing C code. So the robots are taking over because we can write code to make code. So we don't really need students to do code. We just write code to make code and just see how good they compare with each other. Oh, you don't know. Come on. We got an example here. Okay, so just having a look at this question. This is actually a really bad question. Can anyone tell me why it's bad? Yeah, this question is not really good. There's no. This is something we talked about a little earlier. It's not with the string cat, it's actually with the checker. It's not with the string compare, it's actually with the string cat. So because this is a bad question, I'm not actually going to do it because I really don't like bad questions. But so Peter gets allocated 6 bytes of memory. Okay. And we get P, E, T, E, R, null terminator. We also have I. We then concatenate the A here, and we also write a 0 into who knows what. Okay, when I is 0. So this is actually a bad question. So I'm not going to complete it because of that. Okay, but you can see what the problem is hopefully. Oh. Now, if there's a mistake on the exam or there's something that crashes, usually they just get rid of the question if it's got a mistake in it, or they'll fix it in the exam itself. But some math has been through all the questions, so hopefully they'll work. I've read them all, but I haven't checked them all for your exam. Okay, sure. If you want to still go through it, we can. So let's just fix this first, and let's change the size of this. Why is my eraser not working? Do you set the exam? Now I clear it. No, I don't set the exam. It's kind of a combined effort in what we want to learn. But I kind of set what I wanted it to have, and then, yeah. The string cat concatenates 2 strings together, so it'll add it to the end. So let's just put this as 10. Well, I guess enough for it. Yeah, that's enough for it. Okay, so it concatenates strings, basically. It says it in the name. So we have I, and then we have Peter, but this time Peter has 10 bytes in memory. 1, 2, 3, 6, 7, 8, 9, 10. I think that's 10. Looks like 10. So we write P, E, T, E, R, 0. Now, if we specify this, these actually become null terminators as well. It doesn't really matter too much for us, but it is a fact. So I gets set to 0. Is I less than 4? Yes, it is. Then we print out I is 0. What's going on with my mouse? Sorry. Yeah, so we do that, and then we concatenate A, which is A and a null terminator, because it's got the double quotes there. And so we add A to the end of this. And we add the null terminator, but we don't really need to do much there. And then we go up to here, and we've got the update. So string compare name, which is name, and Peter. Are these two equal? No, so they won't equal 0. So string compare, if they're equal, will return to 0, but they're not equal. So it's going to not do this part because this is the true case, and this is the false case. So I becomes I plus 2. So I becomes 0 plus 2, which is 2. Is 2 less than 4? Yes. So we print out I is 2, and we concatenate A to that. Yep. And then we go back up. The first loop, so remember a for loop, works like this. So this is I equals 0. This is I less than 4. This is the code that's inside the for loop. And this is the update, which is this part. So it adds the A and then does this comparison after. Now I've lost where I'm at. So we added an A, then we concatenated another A. So we're up to there, and we go back up. We compare Peter A with Peter, which isn't true. Once again, so we don't do the true case, we do the false case, and this becomes a 4. So now that we're at 4, 4 is not less than 4, so we print out Peter A. Why is it false? Because it's not equal to 0. So remember, string compare returns a 0 when equal. If it was plus plus I or I plus plus, it doesn't make a difference because this never executes. This never happens in this piece of code. It always does this I plus 2. So it doesn't make a difference. Okay, so how do we start? Okay, so we've been running for quite a while. I don't want to get crazy, so I'm not going to leave a question. Okay, let's have a break. Go ahead, break. And then we'll keep going. And if you've got any questions, put them down and we'll go through. The person that was asking about the box and pointer diagram, can you please write down the one that we're talking about? Because I can't find it in the chat. Okay. All right, just say hi if you're back. I'm going to start having a look at this one. Hopefully there's no sticks in it. That's what's fun. Let's see. All right. So with these programs, it doesn't actually tell you which lines to draw the box and pointer diagrams for, where in your exam it will. The one in the practice one was a little long, but it's enough to keep you busy. So I'm going to start with main here. And we'll do these 4 variables. So we have a float, which is C, which is -13. We have Z, which is a float, which is -3. We have D, which is a star float. Sorry, what am I doing? Float star. Which points to Z. And we have a float star star, which points to D. Okay, so that's the first box and pointer diagram that we've got for those 3 lines. We then call our function. So we now have 2 boxes, and on entering this function, so this is func1, this is main, and we're currently in this one. So main still has C, F, -13. It's really hard to write all these small boxes with this, but with a pencil this would be a lot easier, obviously. Star, 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 star. Points there, points there. So we're doing the entry into this function now. So we've got a C here, which is a float, and we've got Z here, which is a float star. C is passed into C, so we've got -13, and the address of C is passed into Z. So this is now going to point here. Okay, so we've done them 3 lines, we've done the entry into the function. And now we need to do the exit of the function. There's no other lines in this. So we'll do the exit. So there's 2 things that happen at the exit. C gets set and star Z gets returned. So we've lost our func1. Not much happened in that. So we've got main again. We've got C, which is a float. We've got Z, which is a float. It's -3. I'm not changing C because obviously that's going to change. And we have G, which is a float star star. And these haven't changed, so they still point at the same things. And we're currently in the main function. Now, star Z is obviously -13. Okay, because we dereference Z once, we get -13. And this gets returned and stored into C. Now, this is pointing at C, so nothing changes really. It's still negative 13. Okay, so we've done that line now. So all of that's been done. Okay, that's what we got. We're now going to look at func 2, and we're going to do the entry to func 2. So now we've got func 2, we've got main, and we still have C, which is a float, it's negative 13. We have 2, which is a float, it's negative 3. We have D, which is a float star. We have G, which is a float star star. This points to here. Alright, my pen just moved. And this points to here still. Nothing's changed in main. Main for all the steps is to remain the same. We also pass dereference D. So dereference D is negative 3. So negative 3 gets passed into our function. Okay, with our one variable, which is D. We have D, which is a float, and we've got negative 3 in there. You'll notice that there is no connection between these. We then get to the next line, which is D becomes 3. Room. So I'll just keep going this way. So we've got main, we've got our func 2, we've got C, which is a float, it's negative 13, Z, which is a float, it's negative 3, we've got D, which is a float star, and we've got G, which is a float star star. This one points to here, this one points to here, and that's all good. Now we've got func 2, which D was a 3, but now it's being set to negative 3, now it's being set to a positive 3. So D float, and now it's 3. Now we've got to do the return from the function. Okay, so we're now back in main, and we're returning this D, which is 3. So this 3 needs to be stored into C. So we have main again. We have C, which is a float. We have Z, which is a float. We have D, which is a float star. And we have G, which is a float star star. Okay. Z hasn't changed. G hasn't changed. D hasn't changed. But we said that we returned a 3 and stored it in C. So that's done. So that part's done, and now we've just got the last one, which is func 3. So we're going to do the entry into the function. So we've got main, and we've got func 3. So let's make memory again. So we have C, which is a float, we have Z, which is a float, we have D, which is a float star, we have G, which is a float star star. We know G points here, we know D points here, Z is negative 3, and C is 3. And we are passing C this time into a variable called G. Float, and C has 3 in it, so this is going to have 3 in it. We then get up to this step, which is G becomes minus 14. So we keep going. So we've got func 3, main, currently in this function. Z, which is a float, we've got C, which is a float, C, which is a float, we've got D and G. None of these have changed. This is a float star, this is a float star star. And that's 3 and that's -3. And the only thing that's changed on that line is G has become -14. Why is G 3? Because C got passed in and C has 3 in it. Yeah, must have made a mistake. If I made a mistake, let me know. But yeah, that has 3. So it had 13, and we returned that 3 and stored it in C. And then we called this function and passed that 3 in. Yeah, that makes sense. So we get -14. Okay. And then we do the return. So we have just main. Which has 4 variables. And we're storing the results in C. The return is G. So C changes, Z doesn't change. So it's still got -3, D, and what's the last variable called? G. C gets -14. That's there. -14. And that's done. That's the whole thing in about 10 minutes. So you should be able to do the same. I doubt yours is going to be this long. It's going to be a bit shorter, but you can still get through them fairly quickly. Even drawing out main every time, it shouldn't take you much longer to draw out. And then if you try it out, you should get -14 and -3. Does that answer your question, the person that asked? Yeah, I did actually mention this to Summer. If you want to use F or C or I or something like that, just up the top before you start, just write F refers to float or something along those lines. Just write that, and that should be fine. Just make sure that you do mention it. In terms of the CSE5 exam, yes, the first part will be exactly the same as the CSE1 exam. Can I explain the flow diagram? Or would you like me to explain? With the flow diagram, yes, you do need to use the right shapes, and that's why it will be a single extra question for the masters that will ask you to interpret code and explain code. So it's more of a written question. It's a more theoretical question. Now, so for the flow diagrams, if you go to LMS and you hit flow diagrams at the top, and you hit symbols, you have all the symbols. So that's an operation. This is a function. So a lot of people forget that the function has these lines. You've got a condition. You've got the return function. You can either use a square or a circle for that. You've got a function entry, and you've got a start and end. You've got an example of a while loop, a for loop, a do while loop again, a function, and an if statement. So if we have a look at a while loop, now you can do it either naturally or with code, it's up to you. But if you know how to do all these, you can pretty much do any question that gets thrown at you. But you should know how to do all of these. So all the loops. This is the if statement. This is if else. This is if else, sorry. You've got a function. Okay. Casual. I like casual. So for your exam, you may want to mix it a little bit. Ideally, for an exam, you try not to, but generally, so you've got two different types of tools. You've got your box and pointer diagram tools, which is a debugging tool, where a flow diagram is a design tool. So generally, you don't have the code when you're creating a flow diagram. You draw the flow diagram as you've been told to do in nearly most of the labs. Not many people did, but it's your practice. And you keep using that to develop and create your code, rather than going the other way and writing your code first. So generally, your flow diagrams are going to be very messy when you're designing code. In this case, it's going to be simple. It's going to be easy. It's not going to be like the assignment or something like that. It's going to be similar to like the practice exam. It was a fairly easy problem. So your flow diagrams can look fairly neat. When using them really, it's usually you have a big whiteboard and you're trying to design something before you start. And so you may have a bit of code, you may have a bit of functions, you may have lots of notes and stuff, but it is a design tool rather than a debugging tool. Okay. So yes, use the right shapes. Will the program we will be asked to write be familiar to us? No, it won't be. It might be. I don't know. All right. So what I might do is I might give you another question and then we can use the flow diagrams with it. Trying to look for another good question. We've done one already. Ooh. This is a really good question. Okay, so I got another question for you. All right. So there's another question. Ooh. And then I've got another good question after this. Sounds quite good. So have a go with that and put your answers down. We'll have the code in exams. What code? I don't know. You may not get the code. It may just be a bit of text. It may be the code. It may not be the code. It could be anything. Generally, you don't have the code when you're creating flow diagrams. It's the purpose of flow diagrams. All right, have a go at that. You can write them in code format. It's not quite code, as you can see in the examples. There's some things that are left out because you're doing it as a flow diagram. So have a look. But yes, you can do it in code format. I'll be back in a sec. So have a go at it, put your answers down. If you don't know, have a good guess. still waiting for some answers. Even a guess. Yeah, I've got an exam. I'm happy to stay around and help, but you need to contribute. So have a go. All right. No idea. Okay. All right. Cool. So let's have a look at this question. So this time we're using the command line. Our program's obviously called prog. It's a lovely name. So we then have our argument vector, which is a pointer to strings. So our argc is going to be 3, because we've got 3 arguments. Our argv is going to be a bunch of pointers, and each of those pointers points to a string. We've got prog, we've got Peter, which is 6, and we've got Smith, which is also 6. Okay, so we've got prog, we've got Peter, and we've got Smith. Zero. And we've got a 3. So this is arg v, which will actually be a pointer to that. Why does it do that? So that's arg v. That's arg c. Okay. It's an array of pointers. Okay, they're all caster. And so that's perfectly legal. We then create car P50. I'll actually do it properly. So it's ugly because it's an array. So then we've got P50 now. I'm not going to write all 50 out because I know I don't need them all. Just looking at the next couple of lines. So this is P, and it stores cars. We've also got I. So we copy argv1 into P. So now we have P, E, T, E, R, non-terminator. These are all characters. Okay. Because this is argv1. Okay. 0th index, 1st index, perfectly legal because this is a string. Okay. We then go argv2, so 0, 1, 2, so we're looking at Smith, and this is also an array of characters, so we go to index 4, 0, 1, 2, 3, 4, and we change this to a T. We then do a for loop, starting at I equals 1, at least at 0. Is 1 less than 3? Yes, it is. So we print out argv1. So we print out eta. We then go back up and we increment I, so we get a 2. And we print out argv2, which is on a new line, which will be SMITT. And then we'll go back up, and it's 3, and 3 isn't less than that, so we return. So it's Peter Smith. Does that make sense? Say yes, no, happy, sad, angry, emoticon, whatever. Then we'll go on to the next question. Let's check what it's that. So gone a bit quiet. So say something if you're in Slovenia. If you want a break, let me know. We can just have a big break. Don't mind. It's up to you. Or if you think you're all good, we can finish off. It's up to you. If you're not going to say anything, there's not much I can do. Okay, I think there's an error. Let's get an email. What we might do. Okay, someone's able to comment. So say hi if you're here. Someone just mentioned that there's an error. YouTube's. Nothing's getting through. All right. So if you can't comment, send me an email. Okay. So it appears no one can type in the chat. So we can go about this a couple of ways. Alright. So what we might do. Let's have a 15-minute break and see if it fixes itself. If it doesn't, then I'll invite people into the Google Hangout. And we can go from there. I think you can only get 10 people in there. But that's okay. I think there's only about 10 people that are commenting regularly. Alright, hopefully, yeah, it fixes itself. If it doesn't, I'll try and come up with a solution. Alright, so it appears that the chat is working again after something weird happened. Time seems to fix all. So we can now go on. So the next question I have here is similar to, I didn't get the last question. What was the last question? I don't know what the last question was. That was the last question. What didn't you get? I don't know. I think he wants help, but I've already emailed him. Okay, because well, that's an easy question. So remember the index, the I starts from 1. So argv0 is prog, argv1 is Peter, argv2 is Smith. So you never, it's argv1 in the first iteration and argv2 in the second iteration. We never talk about argv0. Does that make sense? If this started from 0 and went to 2, then yes, we'd get prog and Peter. So if this was for I equals 0, I less than 2, I plus plus, then we would get the answer you had. But we are looking at these indexes. So how did Smith become Smith? So with this line here, we have argv2, which is the third argument. So we go 2, we follow that down, and this is also an array. So index 0, 1, 2, 3, 4, and that becomes a T. Okay. Cool. All right. So in your exam, you're going to have a question that asks you to write a bit of code given a problem. In the previous year's exams, there's been similar. They're a lot shorter, and they're broken up into multiple parts, where in yours a little bit of one big part. So this isn't a very long bit of code, but as you can see, this is only 12 marks, where yours will be a lot bigger and worth a lot more marks. So it's not that it'll be harder, it'll just be longer. So this is perfect practice for your last question. So give this a go and put your answers in the chat as you go. We'll see how we go. So you're given the structure, which is here. Where am I? Write a function called findModel that takes the following as arguments: an array, struct car t, an integer, num cars, that stores the number of cars in the array, and the string sort model, which contains the model of cars you want to find in the array. The function searches through the array car t structures and prints out the year of the cars which have the model equal to sort model. The function prototype's here. So you can just take that and steal that. You can show, there's an example here. So for example, if we had C array and we had these in our array and we passed in Toyota, then it would print 1999 and 2001. Okay. grayscale again. Okay, so have a go at that and put your answers in the chat. If you don't know, just do as much as you do know. Also, you can use whatever libraries you like have been covered in the subject. So you can use the string library if that makes it easier. So many string functions. Okay. Let's see, more questions. Ah, this is the question. That's a good question too. So I'm not going to give you too much. I'm not going to give you anything actually. I was going to start giving you something, but yeah, I've got an exam tomorrow, so I should be able to pick this apart. So one answer so far. Once you get your answers, just chuck them into the chat. And make sure you read the question. Don't waste time on doing stuff that's outside of the question, like some people are trying to do, because you're just wasting time. Okay, so now we're getting some more serious answers. Okay, so we're on the right track. There's a couple of little problems. Let's copy it. Keep going. I'm giving you a fair bit amount of time for this, but it is a 12-mark question, so it should take about 12 minutes. How are you all going? I think it's been at least a decent amount of time. So check what you've got. So as I said, this is a lot shorter than your kind of question, just because it's not worth as many marks. But you still should be able to do this really quickly. Okay, let's have a look. Beautiful. Got one very, very good answer. We have one very strange answer. It's close, but it's not quite there. Right, so I think most people are on the right track. And thank you for having a go. Don't forget you got an exam tomorrow, so you might as well have a go, even if you're struggling. This is the whole purpose of practicing. There's no point just waiting for me to give the answer, because this question, exact question, is not going to be on the exam. Or maybe it will, I don't know. So the first thing we can copy straight away is just the function prototype. That's quite an easy start to our function, because here we're creating a function. Okay. Now, all we want to do here is go through an array. Okay. So we know we need to go through X amount. Okay. So if we want to go through something, we want to check every single one of them, we're iterating. So some kind of for loop. We'll work out what goes in there in a second. I just create I because I need that. I equals 0. Now we know we need to go through, we want to search through the array. So we want to go through every element in our array. So I'm going to go through num cars, because I know that's how many cars there are, and I get that variable through here. And then I just want to go through each one individually. I don't want to skip any. That's not better. Now, we are now going through all the cars, however many there are. This example has 3. It could be 10, it could be 100, it could be 10,000, it could be 40 billion. It could be any number. It's num cars, so this shouldn't be a constant. Okay, it shouldn't be 3. Now, we then only care about cars that are of this type, the sort model. Okay. So we can get things that we want using if. So we want to know, is our car one of these cars when we're going through? All right. So I'm going to go C array. All right. Because I've got my array. And I want a particular position. So I'm going to go I. This allows me to go through every single one. So the first loop will go through the 0th car. Next loop will go for the first, second, third, fourth, fifth, and so on, up to num cars. Now, I want the model, and I want to compare it with something. So I want the model, and I also want it to be the sort model. Now, one mistake that a lot of people make with questions like this is to put this here. However, we know that with strings, if we do this comparison, it's just going to be pointers. Okay, so we need to use a function, and that's why I hinted at using different libraries. Now we could do this a different way. If the question says we weren't allowed to use libraries, and we might do that example as well, because I don't think you were meant to use libraries in this one. So we can put a string compare here. Now, one other big common problem that a lot of people forget to do is this returns a 0 if true. So we can either compare it to 0, or we could just put a not here to say not 0 so that it'd be true. Because if these two are equal, then it's true. Now, I saw someone put a star here. Now, if I put a star there, I'm dereferencing this sort model, meaning that I'm just getting the first character, which I don't want. I want the full string. Okay. So we've gone through the cars, and we're comparing each model with the sort model. Okay. Now, with this, we've now got the models that we like. So for example, if we want a Toyota, we've got them all. Now we just need to do something with it. So we just need to print %d, and what we want to print is the year of the same model. And we want to print out the year. Okay. And so that's a decent answer for this. Oops. Okay. Now, your question will be slightly longer than this. All right. Does anyone have any questions about this? Are we all happy with this? Okay. So with these problems, if you like, what you could have done is, instead of this, we could have drawn a flow diagram. So some good practice for you might be, when you get some time, is to draw the flow diagram of this, and you can compare this. Okay? All right. So another thing to point out is, generally, and this is just some advice for the exam, if you see anything with an array, usually you're going to have to loop through that array. That's not always the case, but in an exam, like this example, you have to go through everything. You have a look at some of the other previous years, most of them you have to loop through the array. And same with the questions that we've done so far. If you see an array, generally that means there's going to be a for loop somewhere. That's not a rule, that's just something you should think about, just as advice. Okay? Because if you have an array, then you probably want to look at everything in it for most questions. Some questions maybe you want to look at every second one, but still that's a for loop. So the for loop and arrays have a nice relationship. Okay, so I might look at another question. I really don't like this question because it's really unsafe. Actually, I probably won't. All right, so let's do another bitwise question. Then I might go into something a little bit more conceptual, not regarding the exam, and then we can go on to some more questions, or whatever you like. So I don't have a question there. Oh, that's too small. That's it. Oh, it's because I zoomed down. All right, so have a go with that. Bitwise isn't there. Bitwise is easy. Anyway. Bitwise is pretty, like, extremely fundamental to computing digital electronics. So you will get heaps of practice with it, especially if you decide to do electronics or something. And well, some of you are doing engineering. Who's doing engineering? If you're doing engineering, let me know. Cool. So if you're at Bendigo, I'll be taking the lectures there. But if you're in Thunder, I'll be taking all labs there for electronics. So either a good thing or a bad thing, or just to prepare you. You don't get to escape that easily. Right, the labs aren't like the C classes; they're very, very different. It was written by someone else who wrote it very, very well. However, the subject used to be really, really good, and it's been written pretty well. Their assignments, the assignments, unfortunately, and the exams and stuff like that, the funding got cut quite heavily from them, so you don't get as much feedback throughout the subject, which is kind of disappointing because the subject used to be a lot better where they cut a whole heap of stuff out of it. But it's still a good subject in terms of its labs and its lectures. The material is quite good, but the assessments aren't very good, in my opinion. Just because, yeah, you don't get much feedback. It's more just quiz style. Right, so we're going to need some answers in now. So let's go through this. So whenever you have a bitwise question, it's a good idea to quickly convert everything into binary. If you've got your table you wrote up, I haven't got it here, I'm not drawing it again, I've drawn it a million times. You should be able to convert it fairly quickly, but if you want, you can just quickly write it out. So 5. And if you've got a table, you can do that even quicker. So we've got a whole heap of variables. So we've got x, which is 0, 0, 0, 1. We've got y, which is 0, 1, 0, 1. Why is it u? Why is it confusing? Now, obviously, there's leading zeros as well, because it's an int. I don't really care about that. We've got A and Z, which are uninitialized. So we've got this X and Y here. So we can just put these next to each other. Because these are leading zeros, 0 and 0 always gives us 0, so it keeps these leading zeros, meaning everything in front is still going to be a 0. A 1 and a 1 is a 1. The rest don't match up, so we end up with a 1, and we store that in Z. Okay, so we're just going through and ANDing every bit. Okay, so wherever there's a 1 and a 1, this becomes a 1. So now we get to U, and we can put U ORed with X, which results in anyone that there's a 1 and a 1 or a 1 and a 0, we get a 1, so we get 1, 0, 1, and that gets stored in U. So we get 1, 0, 0, 1. So we get 0, 1, 0, 1. We then have U get shifted one place to the left. So we get 1, 0, 1, 0. Now, as we saw yesterday, if we're shifting one place to the left, that's times by 2. We know that this number is 10 as well. But we're not storing it in U. We're storing it in A. So A is going to have 10 in it. Okay. And then we print out the values. So Z has 1, U has 5, and A has 10. How do I get a 10? So we saw yesterday that if we shift, this is a times by 2, and we looked at decimal and a whole heap of octal and everything. But we can look at this as well. If I want to convert this to 10, we have 0 times 2 to the power 0 plus 1 times 2 to the power 1 plus 0 times 2 to the power 2 plus 1 times 2 to the power 3, which is 0, 2 plus 8 plus 0 plus 0, which equals 10. So if you have any number, let's say 1, 0, 1, 0, 1, if I want to convert this to decimal, and I did show this quickly yesterday, I started, so 1, 2, 4, 8, 16, 32, 64. U is 4, but U gets ORed here with X. No, because you've forgotten this step. It would have been 8, but you missed this step. So just to make sure you can see it, I'll just point it out. Sure. All right. You sure? I'm sorry. Maybe another error. Just good. Maybe I'll make it a different color. Right. So I thought I might quickly just go over something. This isn't definitely not going to be in your exam, but just why C and what it actually means in terms of what you're doing. Right. So something that a lot of students don't see the connection with, which if you're doing a language like C, I think it's quite important to understand what you're actually doing. So, as I said, this isn't going to be on the exam, but I think it's until the end of your exam. Yeah. While you're doing the exam, I'll be streaming all the answers. So you can either stay here and watch the answers, or you can go to your exam. The choice is yours. I'm joking. So just to understand what you're doing, if you take your phone with you, that would be the stupidest thing you could ever do. Do not risk it. It's not worth it. The consequences are too high. So we have our C language. Okay. We also have other high-level languages like Java, C++, and so on. Okay. Now C is a little bit lower. It's a little bit more closer to the hardware. So you've got your CPU, you've got your memory, you've got a whole bunch of stuff. But the C language doesn't directly connect to the hardware. Okay. C is actually converted down to what is called assembly language. And this you can actually have a look at if you're interested. It's going to be very difficult to read, but we'll talk about that in a second. And we also have machine code. So we can see that our C language is actually part of a bigger picture. We're not talking about compiling, we're talking about the languages. So with this, our code actually sits after it's compiled in assembly language. Okay? And that assembly language is read by the computer, and it's actually turned into machine code as it goes to run the hardware. Okay? So your C code actually gets compiled down to assembly language. Now, this language here is a very low level language, but we can see it's closer to the hardware. As we go closer to the hardware, we generally get higher performance, but it's generally more difficult. Generally. Java and C++ are even higher, so they're not as difficult as C. But I thought I might quickly show you, and I wrote this up earlier. Let me get my machine up. So I thought I might show you what assembly language goes to. I thought I might quickly show you what assembly language looks like and why we're lucky to have languages like C. So I'll grab my machine. Why is it doing that? There we go. All right, so this here is actually lab 3, the second task, which is the bitwise task. And bitwise, this was one of the easiest labs to write in assembler because it is bitwise. Things like floating point is actually a lot more difficult, which you take advantage of quite a lot in C. But we can see that the structure of the language is very different, but it still follows the same logic. So we have to deal with actual memory now, and we have to deal with actual sizes and actual executions on the CPU of what's going to happen at each stage, and have to deal with actual registers. And this is how very early computers had to do everything, because they didn't have C above it and other languages above it. And they've slowly developed over time. C is still quite old, but this is basically close to the machine language. And I'm cheating here as well slightly because I'm using C functions. But we can make that bigger. But we can still compile and write our code directly as assembler code. And this is just something I want you to understand, because these things are often skipped in courses like this. And if you really want to get into, say, embedded or some really efficient coding, understanding this thing, understanding assembly is really quite powerful. Now, there's not many people that can write assembly. It is a very difficult language, and you won't find many people that actually write it. In C and stuff like that. Plus it is very difficult, and we have compilers for a reason. You don't get the efficiency. But if you want to learn assembly, go ahead. It's a steep learning curve though, and you need to understand how a computer works quite well to get to that level. But as I said, everything can be written in assembly directly as well. And we have this C language to assembly language, which still can be human readable by some crazy people that can read and write assembly. I've only written this lab in assembly, and this is on the x89, x86, sorry, I'm talking about. So yeah, I just thought that was cool. And maybe just showing off. In terms of the other question, all right. So yeah, I don't know. And the other thing is that there's very few people that write assembler, so you don't usually get to show and see how it relates and what it looks like. I know some people are interested because they don't get to see it that often. So it's not like, yeah. All right. See. So I've got some really bad code from an exam from previous years. This was in 2008. So it is bad, but it is still solvable. So I want you to do two things. Firstly, solve the problem, and then secondly, tell me why it's bad. Oops. Maybe we can. I don't know what we can do. I'm going to break a machine. So, what does this print? And what is bad? Okay, give it a go. I'll give you 12 minutes, 30 minutes, whatever. Have a quick break. All right, have a go. Hello, Peter. I don't actually know. I haven't done this yet. So let's do this. Let's find out what it becomes. So we start off with we have a pointer called C1, and it points to 10 blocks, 10 cars. Okay. And they are dynamically allocated. We also have C2, which is exactly the same, except for it's called C2. So we've malloped 2 blocks of 10 cars here. We've returned a pointer to the starting memory address. We then have string copy initial, and the same thing into C2. So we have I, N, I, T, I, A, L, and then an L terminator, and then I, and N, and I, and T, I, and A, and L, and then a null terminator. We then call this function. So these are local to main. And we call this function and we create 2 new pointers. One's a double pointer and one's a single pointer. So we've got C array, which is a single pointer. We've got C array 2, which is a double pointer. We pass the value of C1 into our function for the first pointer. So we get this starting memory address. And for the second one, we pass the address of the pointer. So I might just change color there. So now we have these 2 pointers pointing all over the place. We then malloc another 10 blocks of memory. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 10. And we store the resulting pointer in car array 1. Oops. So this pointer is no longer pointing there. Rather, it is pointing here. And we copy hello into it. Okay. We then create another 10. Let's go here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we copy Peter into it. Once again, Peter's a recurring theme in these old exams. Oh, wait. I forgot to return the pointer. And what we're doing is we're dereferencing car array 2 such that this now points at Peter. Okay. So this still points at C2. Okay. And then we exit this function. So we've lost all reference to these. These 2 are created on the stack, so they just can be considered gone. We still have a pointer up to Peter. We don't have a pointer to hello, and we don't have a pointer to initial anymore. So our code's going to print initial and Peter. Okay. Did anyone get that? I don't think anyone did. So yeah, this will print initial Peter. Okay. Now, we can see that there's a huge amount of problems with this code. We've lost all reference to this. We've lost all reference to this. And we haven't freed all 4 of them. Okay, so there is quite a few problems there. Okay. All right, so what I'm going to do is I'm going to grab another question. Well, this one's a little bit easier. Can I just get a hi from whoever's still here? Just to make sure that you can still hear me. And that you still want to go on and on. And then I'm going to take a break for some food or something if anyone wants me to continue. Or we might wrap up. It's up to you. I really don't mind. No. No what? No, I haven't actually. That's a good point. Maybe we'll just make some error codes. That's a really good point. So I'll give you this question. See if you can do that one. Errors or what is wrong? That's the other thing. So do this question. I'm going to do it at the same time on an old computer. If it runs. Damn it. Come on. This should work. So see if you can get the answer before I can get this to work. Yeah, I know which one you mean. Let's see. I think I broke the machine. So have a go at that. Num equals 1. Equals 3. You guys draw this too quickly. I might do this come back. So we've got num equals 0. Okay. Have a think about it. Because your answers don't seem quite right. Okay, so what kind of answers have we got? Sorry. Okay, so let's have a quick answer. Yeah. Okay. Works. Cool. So we get num equals 2 and num equals 3. So did anyone get the right answer? Can't believe that still works. So let's have a look at it. So this should be a fairly easy question as well. Just do it for me. So we've got num, and we originally set it to 0. Is 0 less than 3? You can view me. Good. Sorry. So we switch num with the cases. Okay. So it's not case 1, it's not case 2, it's a default. Okay, so num gets incremented and we break from the switch statement. Okay. We then go back up and num gets incremented. So we've got a 2. Okay. Switch num with the 2, 2 is less than 3 as well. So we go here and we print num becomes 2 in a new line. We then break from the switch statement and go back up and num becomes 3. Is 3 less than 3? No, it's not. So we exit the for loop and we print num becomes 3. I'll be happy with that. All right. I'm going to go see if there's any food. Do you want me to wrap up, or do you want me to keep going? Let me know in the chat. We'll have a long break, however, before that. Get it out of the way. Because we skipped past num 1. That's where it is. Because num's 0. Okay, so we go to default, it becomes 1, here, and then it becomes 2 here. So we never go into it with 2. Okay, cool. So make a vote. Let's say, let's give it, I don't know, half an hour, 40 minutes, maybe a bit longer. Does anyone want to come back then or not? Okay, let's go food. Yeah. Right, so what's up to you? I don't know, the break will be like 40, 50 minutes, 30 minutes, whatever. But it's up to you. If no one's going to come back, then I'll just finish. That's why I'm asking the chat. Okay. If you're still here, please indicate in the chat. I'm not going to answer people that aren't here. And there's no one still there. We'll finish up. Okay. So we've got a couple of questions. Some for the practice exam. Now, practice exam. I'm assuming these people came late because these questions are fairly easy compared to the ones we've done today. Yeah, easy. All right. Cool. So I'll start with 2A. And then we'll go back to questions a little bit later if people want to go through them. All right. So this question, I think I've covered this like multiple times. This is in the lectures, as I said throughout the stream, and same with yesterday. The lectures are about the theory, not the labs. So there's lots of stuff in the lectures in the exam that aren't in the labs. So just be aware of that. This is covered in the lectures quite in detail, this exact problem. So, you know the answer, chuck it in the chat, and then we'll go through it quickly. This one's fairly easy. If you don't know, just say don't know. Keep going after that. And then we'll go through the first 3 steps of the box and photo. We'll go through some special questions. So put your answers in the chat. As I've said throughout today, basically, I'm here because of your participation. I'm not doing this for myself. I'm doing this for you, so if you participate, then I'll keep going. But otherwise, yeah. So there was a good question. The answer might be wrong in the sheet. It should be to 4 decimal places. It's possible that it's wrong on there. There's a couple of mistakes on the answers. Yeah, it should be. It should be 4 decimal places. Yeah, no, the answer on the sheet's wrong. we weren't really going to give answers. We just quickly put them together. So, but yeah, I think most people have got this one. One person. So basically, we are going through the string. So we have a 4, which goes into A. We then have a comma. Then we're looking for the next integer, which is a 2. So B has a 2 in it. And then we're looking for C, which is 0.995. And let's see. And then we have A minus equals B. So A is 4 minus 2, so we get 2. And then we have C times equals B. So we end up with 1.99. And then we print out the result. So it should be 2, 1.9900. Okay, result, sorry. It's just the answer sheet. What's wrong? Just missing that 0. You can always compile this, so that's why I was really concerned about the answer sheet. You can always try it and see if the answer's right. All right, the second question. Okay, so 0.991. So not every number can perfectly be stored in into memory. This is something you just have to deal with. If this is one of those numbers, yeah, this is a huge area of science. It should come out as 1982. So it should come out as this, but if it doesn't, it's because it's one of those numbers that can't be stored perfectly in memory. Okay. That's not something we've covered in this subject. Some space. Right, we'll find some space. I mean, why? That's weird. Why is it 82? Because 9.991 times 2 is 1.982. It's just maths. I think there's a mistake in one of the explanations, but you can just compile and run them and check them. The question itself doesn't have a mistake in it, it's just the output. Most people pick that up fairly quickly. The other one, I can show you which one is a mistake in it. This one, the answer's right. It's just got an extra 0 here. Like that. All right. So the other question was about the boxing pointer. This is why we don't usually give out answers, because you can compile and get the answers, and if there's any mistake, it's purely up to that. But let's go on and have a quick look at these box and planar diagrams. So that question was in one of the weeks, and it's about half the lecture. So that's just a small part of that lecture. It's not a comma after the two. No, it's not a comma. What are you on about? It's a dot. It's not a comma. It's a dot. That's a dot. If that was a comma, well, all hell would break loose, but that's covered in that lecture as well. So you can read that lecture. All right. No, it's not meant to be a comma. That it wouldn't work there. The question is, there's no mistakes in the question. The question is perfectly fine. It was just missing a 0 in the answer part. If this was a comma, this wouldn't work. That is a dot. The question is perfectly fine. There's nothing wrong with the question. All right. So I'm going to go over the block and pointer diagram again. I know we're kind of bored of that, but most people have mastered this. But there was a couple of questions, so I'm going to go through this really quickly. I don't think anyone's today really had any problems with this. And then we'll go on to some other good questions preparing for the exam. All right, so we have this. So I'm just going to go through the first couple. If you've box and pointer diagram shouldn't be too difficult if you understand the code. It's just a bit of repetition. I don't think really anyone had any troubles before. So we just need to indicate what function we're in. We have main, we have 3 ints. We have x, y, and z. They're all ints, so I'm just going to indicate that with an I. We've got 3, 4, 7. We then have the next code block. Which is this. So we're still in main. We still have our 3 variables from before, which is x, y, z. So z, I, and we have 3, 4, 7. We then have 3 new variables, so we have pointer A, which is an int star. We have pointer B, which is an int star, and we have pointer C, which is an int star star. Cool. So pointer A, now we should go step by step, but we know that none of these interact with each other, so it's not a big deal. Takes the address of X, the address of X. Pointer B takes the address of Y. And we've got pointer C takes the address of pointer B, which is perfectly legal because star, star, and star. All right, next part. We have the call to the function. So we're now passing these values. So now we've got 2 blocks of scope. We can quickly look at what these values are. So we've got X, which is 3. The value 3 is going to be passed in there. We've got the address of Z, so the value there. Pointer A, same thing. It's a pointer. Pointer B, it's a pointer. Pointer C. So the only values being passed is 3 and all these addresses. So I think I'm in my room. So I'm going to just move that over up to here. And so we should have main, which has our variables. So we've got main, we've got X, Y, Z, which are all ints. I think it was 3, 4, 7. We had pointer A, which was an int star, and pointer B, which was an int star. We had pointer C, which was an int star star. We then need our new function. I should also do the pointers. A is to X. A is to X. B is to Y. Actually, I want to do that the other way. So get a bit of room. And C is to B. So that's all good. And now we need our exam function. And we have this here, which makes it a lot easier. So we're introducing 1, 2, 3, 4, 5 new variables. So we have E, which is an int. We have F, which is an int star. We have G, which is an int star. We have H, which is an int star star. And we have I, which is an int star star. And we indicate that we're in this function. So now we just pass the values. So 3 is passed into E. We have the address of Z passed into F. So it's an int star, so that's legal. We have pointer A is passing its value. So the value in pointer A is this. So G holds a pointer to X. Then we have the address of pointer B to H. So this points to here. And then I takes the value in pointer C. So I also points here. And that's basically it for that part. So I'll just go through the first 3 steps because it should be fairly easy by now. Right, are we all happy with that? If you say yes, if you are, say no if you're not. If you're still here, say yes. I just want to make sure that there's still people here to justify continuing. And then we'll go through another question from the question bank that I've been going through today. So this is another one which isn't too difficult, but combines a lot of topics together, which is good. But Why is it missing? That's not going on. I'm just going to modify this slightly, just so that it has like a mane or something, or a body. This is kind of weird otherwise. Oh, go away. So what I'm just going to do here with this question is just add int main and a bit of a return as well. Then it's just hash include standard AR.h. Okay, so sure, let's go through this question first. So have a go at this question, and then we'll go over practice. I prefer not to go over the practice exam because these are new questions and we already went through them and you had your opportunity to ask questions. So I'll prefer to stick with some of these questions first and then we can go back to those. But yeah, I'll have a look at what's too late. Really? Yeah, sure. Okay, so do this one first. I have a couple of other questions still lined up from the bank we've been doing today. And then we'll go back to the practice exam. So have a try at that and see what you get. I'll give you about, let's say, well, how many marks is this? This one's, oh, I've lost it. I think it's an 8-mark question. No, it's a 9-mark question, so about 9 minutes. So have a go and put your answers in the chat. Let's go to static. It's too easy. So once you got an answer, put your answer. If you don't have a proper answer, put your guess. Explain what you got up to, explain what you do know, what you don't know in this question. And it should take about 9 minutes. But I'll give you a tiny bit of extra time if you need. haven't got any answers yet. Come on. I think it's been longer than 9 minutes. I think all the other guys from before left. So give your answers. If you don't know, say don't know, give your guess. What would you put on an exam for this question? This isn't a very, it's a moderate question. There's nothing outside of this subject. I'm going to wait till there's answers. If you don't. If you don't know, just say don't know, etc. Well, what's your educated guess or educated answer? I think the live stream's a bit dead now, so I might finish up soon. Have we got any answers? Okay, so this one isn't hard. I missed the table from before. All right, let's quickly go through this. Okay, so we've got an int, which is called num, which is 2. We've got a float, which is called dec, which is 0.2. We have a string, which has 7 characters. Cool, we got an answer. Let's see if it's right. Thank you. So we've got 7 characters. We have character S, we have the character P, we have the character O, we have the character R, we have the character T, we have the character S, and we have the null terminating character. We then call our function. Our function introduces some new variables. So we've got n, we've got f, which is a pointer, and we have p, which is a pointer. Now, I'll just note that this one's a float and this one's a car, because I think that's quite important. And we pass num into n, so n has 2. We pass the address of dec into here. So we've got the pointer to here. Now, and we've got p, so we've got k plus 2. We know because this is an array, it's a pointer. So k plus 2 is going to be here. So our character pointer just points to O. We're now inside this function. We introduce a new variable called I, which is nothing yet. We've got n becomes int dereference f plus 5. So dereference f, we get 0.2. We then typecast it, which was done in week 2. So this becomes 0. So 0 plus 5 is obviously 5. We then get to the next line and we have dereference f. So we've got 0 0.2, 0 0.2 plus 20 is 20.2. We then store the result in dereferenced f. So we follow the line and we get 20.2. We now get into a for loop. Oh, I stored that in the wrong place. That should be 5, sorry. Oh, that's it, that's I. So I equals 0. Sorry, on this step it was to n. I didn't even check the variables there. But you could easily pick that up when you get to this line. You realize that it's overwritten. So now we get here. I is 0. Is 0 less than 5? Yes, it is. So P0 becomes K. So P points to here. We dereference this because it's an array. And so this becomes the letter K. We then go back up in our loop and I equals 1. Now, so what we do here is we're continuously looping, and we're looping 5 times, so we can already pick up what's happening without having to read too much here. So we can see that it's putting 5 Ks into here. So we get a K, we get a K, we get a K, and we get a K. Okay, so that's all good. The pointer hasn't changed its position, but we've just gone 0, 1, 2, 3, 4. As we know, our for loops will go from 0 to 5, adding 1 each time. Now, we can also note that there's no null terminator, which we talked about earlier. But here, we've got P5 becomes 0. So 0 plus 1 plus 2 plus 3 plus 4 plus 5. So there's a null terminator here. Now, this is bad, but as I said earlier, some of these questions aren't quite right. So what I'm going to do, just to make this a little nicer, I'm going to make this 8. These exams are quite old and they do have some little quirks. It's the works, it's just that that's unsafe. And then we return H to K3. So we're just saying H becomes K3. So K0, 1, 2, 3 becomes a H. Okay, and this is all gone because we're outside of that function. So now we print out num, %d. We print out dec to 1 decimal place, so 20.2. And we print out our string, which is SP, KH, K, K, K. Some people got a close answer, but not extremely close. Oh, it's the one person. Okay. So that's, yeah, a moderate question. But you should all be able to do something like this. So do we want to go back to the practice exam questions? Or do we want to go through a new question? We can go through that F if you like, but I think it's been, it should only take 2 minutes to go through. I'll do that question. I might just go through it because it's fairly easy. Most students have done this in the practice exam. The revision sessions. I don't want to waste these with stuff we've done already. Right. So we have num, which is 1. We have I and j. I becomes 0. 0 is less than 2, so that's good. J becomes 0. We all know how to use a for loop. 0 is less than 4. Switch case. Num 1. 5 is not a 1. 2 is not a 1, so we print out a 1. We then increment 1, so now we get 2 here. And we go back up. J gets incremented. 1 is less than 4, so we keep going. Switch case, we've got a 2. Case 2, we print out a hash and then a space. We then break from the switch, so we increment num again to 3, which is here. We go back up. J gets incremented, so now we have 2. 2 is less than 4. Switch case 3 with num. 5 is not 3. 2 is not 3, so we default and we print out 3. Num is incremented again, so we get 4. Then we increment j, so we get 3. Is 3 less than 4? Yes, it is, so we go in here. We switch 4 here. 4 is not 5, 4 is not 2, so we default and we get 4. We then increment num again, so that's 5. J becomes 4. Is 4 less than 4? No, it's not, so we exit that and we print a new line. So now we're here. We go back up. We increment I. So now I is 1. Is 1 less than 2? Yes, it is, so we keep going. J gets reset to 0 in this for loop. We then check, is 0 less than 4? Yes, it is. We have 5 here. Switch case 5. 5, is 5 equal to 5? Yes, it is. So now we print out star and a space. We go down because we break. So now we add 1 to num, so we get 6. And then we go back up. J becomes 1. We then, is 1 less than 4? Yes, it is. Switch case num. 6 is not one of these two, so we just print out the 6. We increment num. I think we can already see that we don't need to even do the calculations here because we know what the last two are going to be 7 and 8 given the pattern. So it's 2 less than 4. Switch 7 here. Obviously, it's going to be the last one. We increment num again, which becomes 8. We increment j, which becomes 3. 3 is less than 4. 8 is default, so we print 8. We increment num again, so num's 9. We increment j again, so j is 4. Is 4 less than 4? No, it's not, so we exit that. We print a new line. We go up, back up to the for loop. We increment I, so I is 2. Is 2 less than 2? No, it's not, so we're done. And our answer is that. Does that make sense? Let's go through. Cool. All right, let's go through some other questions. All right. Actually, I'll do a string func one. I'll skip to one of the string functions, which was a week's worth of lectures. All right, so have a go at that. This is a 6-minute question. So it should take you 6 minutes. So have a go, put your answers in the chat, and we'll keep going. So it should take about 6 minutes. Oh yeah. Done. Straight. Easy. It's right. You want to check your answer. I haven't gone through it yet, but you may want to check your answer. We'll find out very soon. There's some good answers there. Like the other players. No, the string length does not include the null terminator. That's something you should remember for your exam with all the other functions, the string functions that you need to know. Thanks, Bert.
Hello, Matt.
Hello. Give me a second. I'll give you something.
Hello. Can you hear me?
Yeah.
Oh,
You're
cool.
live.
How's it going? A bit low.
Oh, no, I said you're live.
Oh, yeah, cool. Oh, no worries.
If
How's
you
it going?
All right. If you give me this link here, I just sent it to you.
Yep.
Facebook. You can see the chat.
Oh, easy. Cool. All right, sweet.
But, yeah, I think most people who have left now.
Oh, okay.
Oh, no, they're starting to come back again. So we're just going through questions.
Yeah, easy. How's it going, guys? You keen? Oh. Oh, too easy.
Who is this? Is this just some random guy that showed up? You know. Yeah, I noticed that too. That the screen is going black. I don't know what that is.
Yeah, that just happened then. I think.
Yeah. Oh, you know
It-
why?
this is- Oh, yeah?
It's fucking Roseville.
Oh, is it? Oh, is it switching to me or?
Yeah, it's when you talk.
Oh, no way.
I just fixed it.
Okay, cool. That's really funny. Yeah, because I've got my like camera off. Oh,
Yeah.
it's on, but like it's blocked, so like it's like something's covering it. That's really funny. Okay. Very
All right.
cool, very cool.
So I think we've got quite a few answers there, and not bad answers. So let's quickly go through this. Both just smash something.
Sorry, I'll turn my mic down or off.
That's okay. So we have this this string firstly here, and we know this is 3 characters given what we've done in the past. At an angle. So we have 3 characters. We have E, X, and the null terminator. We also have a long string, which is 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 characters. We then have the string copy, and we copy the A. Now, it is really, really, really important to remember this is 2 characters long. So we've got the A and the null terminator here. We then have this while loop. Now, a common mistake that a lot of people make with this string length is that they count the null terminator. It doesn't count the null terminator, and if you have characters after this, it will count up to the null terminator. So currently, what is the string length? Bo doesn't know.
It could be something, any number. It's a number, right?
Could be a number.
I can't be answering it. It's not my job.
Yes, so that's 1.
There we go. Yeah, nice.
So it doesn't include the null terminator. So
0.
Cool. So we've got 1. Is 1 less than 5? Yes. Okay. So why is it 0? Long string has had an A copied into it. Okay, it's got 1 character in it, up to the null terminator. We then use string cat. So string cat concatenates another string to the destination, starting at the first null terminator, which we saw some interesting ones that have multiple null terminators earlier. So we attach st, and this is st, so we get ex. Okay, and we also get the null terminator moving to there. We then get this st1 becomes b. st0 is here, st1 is here, so this becomes b. And we go back up, and now we do this comparison again. String length is now 3. 3 is less than 5. And so now we concatenate this to this. So we get E, B, oops, 0. And we set st1 to B. Okay? And we go back up and we do this comparison again, and 5 is not less than 5. And so we get EX, XE, B.
That's a good question.
It is a good question. There is a couple of problems. So I'm going through the really old exams, but Jeff doesn't
Yep.
seem to care about allocating enough memory for each strings and the answers.
Oh, that's not very good, is it?
No,
Uh,
no. So one thing to note is there's no 0 there. That is the null terminator. So as we talked about a lot earlier, what am I looking for? Oh, the ASCII table. So as we talked about earlier, the 0 is the null terminating character, telling us where the string ends.
yeah, the character 0 is very different. You can probably look at the ASCII value for that if you guys look up an ASCII table.
Well, we can do that. Very awesome. The ASCII 0 is 48. Okay. So this and this are very different. How do you show it? You don't show it. It means that that's where the string ends. So
Oh, no, I think she's saying working out.
there's no need to show you working out.
Yeah.
But, so in memory, you show it without the quotes, or you can show it as this character. But when you print out your answer, if you don't have the null terminator there, rather it is here, then it just means that that text will go in. I might actually do a really quick example. So, Chris's question, printf and scanf in the same space. No, you need to separate them because they're both functions. So remember, a function block is that. And so each function should have its own block in the flow diagram.
So I just have to leave.
That's all right. It's nice. Nice seeing you.
No, I don't leave now. No. I was
Okay.
gone for like 2 seconds.
No one noticed.
Sorry, mate.
No one noticed. It's okay.
Good?
Don't worry, I left for an hour. So.
Nice.
So let me just do a quick example. So car A, let's say,
Hey, Matt.
let's say this is my string, okay? Now in memory, how many characters is that? It's 11. 3, 4, 5, 6, 7, 8, 9, 10. I think I did an extra. So in memory, we have the letter H, we have the letter E, we have the letter L, we have the letter L, we have the letter O, we'll have the space character, we'll have the B character, we'll have the E character, we'll have the A character, we'll have the U character, and then we'll have the null terminator. Then we are going to go A4 becomes 0, okay? So we're going to insert a null terminator here. So now I'll write printf %s A. What gets printed? I just had to cut you out.
Wait, you did what to cut me out?
I inserted the null terminator.
Ah, no. This chat man talking about nuggets.
Yeah.
Hell. So again, some answers. Hell.
Hell. Oh, did I do something wrong? 0, 1, 2, 3, 4. Oh,
Yeah, you did.
oops.
That's a nicely done, Code as.
Can we do 1E in 2011? Sorry, that was my mistake. Yeah, 4 is here. It's counted wrong. So it should print Hal. Unlike your exam.
That's awfully. I was about to say it's an awfully dark example. That made it funny though.
Yeah. I need to find which one's which. 2008, 2009, 2010.
Yeah. Chris also had a question just up, scrolling up a bit.
Yeah.
He said, a bit off topic, but when drawing flow diagrams, can we put printf and scanf in the same space, or do we need to separate them?
Can I answer that?
I don't think so. Maybe.
But
I may have potentially missed it. Okay.
but I will repeat with Bo because he's doing the exam tomorrow as well.
Yeah.
What's it called? What was I going to say? Yeah, they should be separate.
Okay. All right, kick that guy out. Get out, Alex. Beats it.
Oh, you can't kick. I can enter as a moderator. And then you can kick people. I can put people in timeout as well.
Yeah, thanks, Beck.
What's 2010? 2007, that's 6. Oh, 2011, not 2012. Okay, so E. So cover nothing that we haven't done before. Yeah, that one looks fine. Yeah, we can do that one. All right. So someone asked about a question. Yeah, so this is all. Okay, so well, it's fine. Okay, so this is quite an interesting question, but all right, so this is the next question. Someone asked to do this question, so I'll give you around 6 to 8 minutes to do this one.
Dude, this chat, man, it's hilarious. The real fight is the exam score.
Is it really? This is something that I mentioned earlier.
Yeah.
Some of the students were like, oh, the exam should be easy. I'm like, yeah, it doesn't really achieve much of your future.
No.
Anyways.
Well, that's true. I mean, yeah, when you're actually programming, doing work, you don't do it under exam conditions.
I also I was showing before, so I coded up because some of the earlier guys were kind of interested. I coded up a couple of the labs in assembler.
Yeah, that's pretty hardcore.
Yeah,
I've never touched assembler. I'm out.
Sorry.
So they know more about me, more than me.
No, I didn't get through it.
No, that's some hardcore stuff, man. I won't touch it with a 10-foot pole.
It's quite interesting going from the 8-bit to 32-bit.
For assembler.
Yeah, the learning curve just goes up fucking heaps.
Well, how many instructions are there?
So I'm using NASM, and there's
Because
let's see.
yeah, because I did OSA, and they had the 2 major instruction sets. One was tiny and one was huge.
I'd say it's about 100 or so.
Yeah, that's ridiculous. No.
This is Intel's x86 that I'm using, but it's a restricted set. Actually, there might be about 300.
Yeah, no, that's what I remember being about 300. It was just some silly amount, and then when like mobile phones, like smartphones came out, the instruction set was too large, so they decreased it by quite a bit. So smartphones have a much
It's RISC, reduced instruction set.
Yeah.
RISC.
Which ends up actually being faster, I think, because a lot of it's quite optimized. Well, it's more optimized than a person can do it.
It depends, because you can have, without RISC, you can have hardware optimization. So they're slightly slower, but we have, like, if you're going to use it once, then you don't need hardware optimization. It's a balance, and it's also price as well. So we put all this hardware to make one single instruction that does, I don't know, let's say you have an instruction that does a hash table, which is like fucking huge amount of hardware.
Yep.
Is it really worth it? And how much is the cost going to go up?
Yeah. Yeah, well, that's the thing.
Like
Expensive. No, I thought.
And just physical size as well, stuff like that.
Yeah.
Well, you can just get you can get more registers and stuff like that, so you can do even more operations with a reduced instruction set. All right, so we got B5. Let's go through this. So we got int main. We have a car, which we'll call Y, and we store B in it. Note the little quotes to indicate that it is a character literal. We then have K, which is a pointer. We haven't stored anything in there. So I'll just indicate that. We then call this func Y. So let's move up. I'm running out of space. I'm going to move these up over here. Wouldn't that be nice if you could do that on a whiteboard?
Yeah, one day.
Well, technology's been around for like 10 years.
Oh, is it really expensive?
Well, it's expensive and no one really likes it.
It would be cool just to have Photoshop on like a big whiteboard though. Let me see.
All right, so now we get here. So we create our variable first. So I'm going to treat the scope of this function down here, just to make it a bit easier. So we have x, and it has b in it as well. And then we create this n. So we allocate one int, okay, one int, and we have this n, which is a pointer, and it points to that single int. X becomes a, those listening to the stream. We then dereference n and store 5 in it. So now we have 5 there. And then we return n. So we're returning a pointer. Okay. So this pointer gets stored in K. Okay. And now we just print out the result. So we have Y, which has B. We don't have any reference to that anymore. And we have star K, so we have 5. So we have B5.
Yeah.
Now, what have we forgotten to do in this problem? I blame Jeff.
That isn't good. That habit.
There's no fucking freeze anywhere. There's one question which, like, it loses 2 full arrays. like just completely.
Nice. Not good habits. This is a good question though, because I think this is the first time I've actually seen in C or in any of these exams where they create memory without a name. Like they create the int, but you don't actually allocate it to an actual int variable.
What are you on about?
Oh, like I mean, that's not true. Like we do. It's the way, just like creating a single value using malloc. That's what I meant. We haven't seen like an instance of creating one single value.
Poor thing. Well,
there we go.
You can times it by 1 if you really want.
Oh yeah. But no, I just mean like it's an interesting use of it.
It's kind of a poor use of it.
Yeah.
Let's get another question. We don't get the value of x back. X is lost in the abyss, but that's okay because it's a local variable to that function. It doesn't matter.
So is n as well, but we return the value of it to another variable.
Yeah, so that's actually really important because we've got the malloc, we can still free in main.
Yep.
Because if we didn't return that n, then we'd have to free inside that function. Does this have anything that we haven't covered? Yes, it does. Oh, that was a good question.
Yeah.
There's a couple of string functions that we haven't covered, which is kind of annoying. Oh, I like this question. Let's see if he does something dodgy. I think he does. No, I think that's a pretty good question. So this is around about an 8-minute question. So I'm going to chuck this one up.
I'm expecting good things, man. You got excited about it?
No, I'm not excited.
Oh.
I'm running out of questions that are good.
Yeah. How many have you gone through today?
Too many.
Mm.
Too many.
Tuesday drinks. Doesn't the exam start at 9? That means you'd be drinking. Oh, that's not too bad. It's after 12, technically. Yeah, have some cereal and vodka.
I don't know. I think you'd easily get away with bringing.
Oh,
vodka.
yeah, I've seen people bring Maccas into the exam, man. Like people have brought like a Big Mac and chips and stuff. You can bring what you want, really. I mean, yeah. They still check it, but yeah.
Yeah, I've heard of people bringing vodka in before. But we're not encouraging this. Not that I really care. Like, as long as you're not cheating, I don't really care. I hate cheating, but yeah, but Durban's not clear.
Well, maybe someone wants a challenge. I don't know. Maybe they'll find it really easy and they want to make it a bit difficult. Some vodka beforehand.
Anyways, there's a question. You should do that.
We could just do vodka. Up to you. Is it the last exam for most of you guys? Curious to know.
I think it is. It's like the exam period ends next week, doesn't it?
Well, ends this Friday.
Friday. Yeah, the question.
Oh, no.
Do the question. Give you 8 minutes. If you can do it, you get a shot.
Nice.
First exam. First and last. It's Thursday, bro. You're wrong.
No. Oh, he does too. Kind of random the day. It's like the last Friday of SWAT back and then ends on a Thursday after 3 weeks. It's kind of weird dates.
There'll be no reason behind that.
You don't reckon there would be? It's kind of inconvenient, to be honest. It's like,
Oh, yeah.
I mean, you could get an extra weekend studying just by shifting it 1 day forward.
Have you got any answers?
Not yet. Checking up the bourbon. Yeah, end of exams is always the best. There's no better relief, actually. It's so nice. And then you realize in a few weeks you start all over again.
Yeah. The makeup exams, because everyone will fail.
Exactly. Well, it's been how many years? I'm still doing C, man. So I don't think people realize. That's why I started doing computer every lab. I was actually doing the lab with them.
One day you get C.
I know. It's just hard, man. I drink too much vodka before the exam.
What's the first bit? The first folder? So is that an answer, or is that just someone saying something incorrectly? And we've got a THI. Right. I'll wait till we get a couple more answers and we'll go through it. Yes, possible. Maybe this. Cool. And have an educated guess. On the exam, don't be afraid to have an educated guess. There was some like the exam questions from last year. I think I remember that. There's 2 printfs, and they were constants. And so you could just do the question and just take a gamble 50-50 because there's only 2 possible prints. So as long as you understand that, you can take an educated guess with a lot of this stuff. Doesn't mean it'll be right, but you can work out what you do know, and from that, make an educated guess. All right. You know,
This one's
what is it?
yeah, no, but I'm just looking at the space character.
I haven't even done it yet. I'll have a look at it in a sec.
Oh no, what am I doing? I'm doing no one. Hang on. No. I'm just being a nub. Don't worry.
Like Jeff does all these string kind of ones where it changes into something unreadable.
Yep. String numbers are. Jeez. All right.
But like I've been through a bunch of them and they're just like garbage at the end. But wouldn't it be cool to like have a question that's like you send messages to the students in the exam by changing the stuff around?
Yeah.
This, if I change it to this answer is wrong, or something just to confuse them. All right, let's go through this. I think I've got quite a few answers. I need to change from grayscale to RGB. I'm going to add another layout. All right, so we've got numbers, which are ints, and there are 5 of them. We have car, which is 30 long. I don't know if we'll need all 30, so I might just do a dot, dot, dot. Now.
Got some answers that are closed.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, dot, dot, dot. And we've got, there's actually enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a little bit of a
Should never get one answer that's correct.
What if your answer's wrong? What if their answer's wrong?
Wait, what if my answer's wrong?
Yeah.
Oh, well, could be. I mean, that's always a possibility.
It is.
Although, is it, Matt? Is it?
Yeah, it's quite possible.
There's no faith, Matt. No
I
faith.
don't think I've made a mistake with the answers yet, but I've made mistakes in the working. There's a couple of mistakes on. You remember your bitwise, how you did the bitwise that Josh said no one could understand?
Yeah, yeah.
That was wrong. You had an extra 0 in there as well.
Oh, did I? Okay, whoops. It got fixed right though.
No.
All right, Josh, that's exam failed. Sorry, man. That's it. So give me the question.
All right, so we create another variable, which is I.
Josh?
And
That's not Josh Millwood, is it? No.
no.
No, okay. All right.
All right, so I is 0. Is I less than 5? So now we go into this loop and we've got numbers 0. So this is the numbers. We should write numbers. Yeah. And we've got I plus 2. So this first one is 2, and then we go back up. I is incremented by 1. And so is 1 less than 5. And so now we've got I at numbers 1 becomes I plus 2. So we can see this is going to be 3. And we know this is going around 5 times. We've seen for loops multiple times. And we know that this number I is going 0, 1, 2, 3, 4. We know this I is going 0, 1, 2, 3, 4. We know this is plus 2, this is plus 2, this is plus 2, this is plus 2. So this is just an alternative way to look at for loops when you're doing an exam, because you just do it in one step. And you can go 4, 5, 6. Okay? So you just look at all the steps in one. And this is called unrolling the loop as well.
I know this, Josh. Sorry.
We then get to our next for loop, and we reset I to 0. And we have a string, and then we have a another array inside that. But we'll get to that side in a sec. Let's evaluate the right-hand side first. So string I, which is T, we'll now evaluate this. So numbers I, so number 0 is 2. So we have a 2 here. String 2 is this one here. Okay, so a T gets stored in 2. So we have a T. We then increment I by 1. Is 1 less than 5? Yes. So now we go string I, so string 1, so we have a H. And this H is going to be stored in numbers I, so 3. And we've got string 3, which is this one here. So the H goes here. Okay. We then increment I again, and we get 2. We go back up. 2 is less than 5. I at 2 is T. Okay. So it's capital T. Then we have numbers I, which is 2. So we have 4. String 4 is here. So we have a big T. We then increment this again. We get a 3. We go back up. 3 is less than 5. 3 is H here in the string. Numbers 3 is a 5. We're nearly done. String 5, 0, 1, 2, 3, 4, 5 is here. So we store a H here. We increment this again. We get a 4. 4 is less than 5. String 4, 0, 1, 2, 3, 4 is a big T. We then go over here. We get a 6. String 6 is here. And so we get like, confuse myself. So many variables. That's a T. 0, 1, 2, 3, 4. Yeah, that's a T. And that's a 6. And so 0, 1, 2, 3, 4, 5, 3, 4, 5, 6. Beautiful. So we get a T here. And then we print the string. So we get TH, 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 T, long. Okay.
Yeah, Henry got it right.
Of course he did. The answer is this. What is all this crap?
No, you got it above that one. Hang on.
Oh, you just... We gave
What?
this...
I gave it away. I gave it after you did the answer.
Yeah, let's get T from string 4. 0, 1, 2, 3, 4. There's a T in there.
Yeah, you can kind of see the pattern after you do the first two because it's just going to repeat itself, but with 5 characters. It's an interesting question, though.
Are you fighting the students?
Yeah, fighting 1v1.
You're allowed to encourage them to fight each other, but you're not allowed to get involved.
This is virtual fighting, so it's
Oh, that's boring.
oh, it's about the.
Okay. I want to do another bitwise one. This one's kind of boring. I might make my own bitwise one up. So to use, I'm going to use shorts. I like shorts. Let's get our 0x 42. And then we're going to short y equals 0x 8a. We go short z is 0x 1, 3, 2. I'm then going to go x becomes x shifted 2 places. I'm then going to go y becomes, let's say, z and not x. I'm then going to say z becomes z shifted 1 place, shifted 2 place, board with y XOR x, and then we'll say x is z or y or x. And then we'll go printf. That should keep you busy.
Now this is a question.
And then we'll do a hard one. I'm not telling you. Go. All right, I'll give you 10 minutes, let's say, to do this. Maybe a little bit longer, then have a quick break. While you guys do that, maybe go entertaining, maybe not. Get a breakthrough.
Probably not. I don't know. I'm not very good at stand up.
Well, you gotta.
I'll just put on copyrighted music and get.
Oh, please don't. Don't do that again.
Was
Was that you or Josh?
It's Josh.
Ah, fucking. Yeah, don't do that. Right, have a go at that. Or have a go at that. Make sure that
I will.
I haven't made any mistakes.
I might have a break as well, but I'll do the question. I got muted in chat because I sent too many messages. Rip.
That's so funny.
Well, it looks like I'm not typing anything. I don't even get special status. This is ridiculous, Matt. What is this? Someone unsubscribed. No, we're going for 5 million. We're going for platinum. Yeah. No, tell Josh I'll be there soon. Don't unsubscribe. Who this
What?
is?
Unsubscribe from what?
Who is Mello? I would have no clue.
Who unsubscribe from what?
From your channel.
Oh, I don't get. There's like I don't know 400 videos and like only 10 are like public.
So underappreciated. Oh, right.
So I really don't care.
I was gonna say you pump out the content, but yeah, 10 public. Now it's a good idea to store all the stuff that you do so you can share it and whatever.
Yes. Well, one got shared by Wendy today.
Oh wow. What was it?
The video that I was creating, the animation.
Oh yeah, that's really good.
So
We should get some feedback on it. Should play it.
no.
Okay, no mind. Actually, it's probably not a good idea because it's yeah, no mind. It is IP, so
It is IP.
yeah.
It's private videos.
Don't worry, Beck. At that rate, you'll have heaps soon.
You'll have 2 in a long.
Yeah.
All right.
After handing,
Did anyone get an answer?
dude, I gave up. It's a really long question.
You suck. All right. Five more minutes. Okay, I'll give you 5 more minutes.
Okay. All right, I'll try and do it in a sec.
Yeah, I have to do it.
No, I'll do it. I'll do it.
Oh shit. I probably should have printed these out in hex. Sorry. I can't delete. Sorry. I didn't mean that. Yeah, I'm gonna change these to X's. Sorry, it's the person that finished it. Just to make it easier for everyone. I'm gonna wait till that person that said 5 more minutes is done, then we'll go through it. We should do it. I've got my Win 3.11 running
Oh, yeah?
C now. So I did one of the questions in that. It's got a it's got a fucking master bugger.
Wait, what's this? Wait, what were we talking about?
I've got Windows 3.11 running C, but it's Turbo C. So
I love that name, Turbo C. C to the max. Like fast and C.
Well, it's a completely different compiler that's known for being broken.
Yeah. Well, for a name like Turbo C, I don't feel quality, if you know what I mean. It's like.
Well, it used to be very commonly used until GCC took over.
Yes.
But yeah, I'll show you later.
Alright.
I'll do one of the questions. It'll have to be a smaller question because it's kind of a pain to write it.
Yeah, I'd be interested to go through old operating systems and check them out. You should do like a YouTube like video kind of exploration of old operating systems and the nifty features about them and stuff.
But I don't
They're
like
pretty good.
randoms.
Huh?
I don't like random people. I don't
Oh.
care about random people.
That'll be a cool YouTube series though.
I'll do a series.
And
just for you.
you can kind of review the operating system and why XP was the best. I mean Mac OS.
2 more minutes. So I'm going to start doing, actually, I'll leave it. Wait till this person's done. I'll be nice. They are asking for time.
All right, I think I got it. Potentially.
I've also got SimCity, the original one.
Dude,
Play that.
there's some classic games. Like, I need to go back and play them. So
No,
I missed.
no, really original one.
No? Well, I haven't, yeah. I can't imagine there'd be much stuff in it. Is there quite a bit? Or like, in terms of features? Or
What, in the original?
yeah.
I'll show you later.
Well, you can build like a house and a skyscraper. And played Roller Coaster Tycoon, best game ever for that kind of management stuff.
Wait, I'm getting it up.
Yeah, just hang on, Josh, bro. I'll be there in a second. All right. Just keep waiting.
What is that?
GG. Although you can get Adam on Windows too. I hate this question.
Why?
I think everyone's feeling it.
Good.
Yeah. Oh, you'd be glad to know, Josh, this is actually half of one question in the exam. So it's only half of it.
This is the one that they have to write themselves.
Yeah. You give a get to this value. Sleep is generally best, I find, but it depends on the person.
You don't need much sleep though.
Oh, well, you don't need much sleep.
Eating's simple.
Yeah,
I agree with that. Though I don't usually eat during the day. I usually eat
a big breakfast and yeah.
Have we got that person that said 2 more minutes? Give me an answer.
So what did I get? I got 1, 3.
Can you type in the chat? Or are you still blocked?
I'll try now. Hello. No, I'm not blocked anymore. There we go. Nice.
Okay, cool. Everyone's got an answer now. So, let's go through this. So, as I said earlier, and I've said many a times, you need to know how to convert from binary to hex and hex to binary. I guarantee you need to know how to do that. Okay. So, with a question like this, if you see a whole heap of bitwise, the first thing you should do is just convert everything to binary. Now we're using shorts, so that means that they're 16-bit. So just keep that in mind when you're doing this. I'm going to ignore the leading zeros here for the other parts, but we've got 0, 0, 1, 0, so that's that. We've got 0, 0, 0, 1, 0, 0, 0, 1, 8, and A is 10, so that's 10. And we've got, I might actually include the leading zeros here, just for fun. We've got 3, which is 0, 0, 1, and we've got 2, which is 0, 0. I don't think I've made any mistakes there. It's a bit hard on this computer to see what spaces are. So I'm just going to put little dots and dashes. So we've got this X shift. So we shifted X across by 2. So what I might do is write X here, just so I can see what's happening to it. X only changes twice. So we've got 0, 0. So this 1 needs to move across twice. So this becomes 1, 0, 0. This X moves across twice. So we end up with a bunch of zeros in the next nibble. Then we end up with 0, 0, 0, 1. We also know that this is 16 bits, so we end up with 3 zeros in front. Okay, so X is done. Okay, X has been stored into X, so that's what you should have for X. Yep, that looks good. We then get to Y, which has a two-step process. So we've got the not X. So not X, we need to be careful because it does include all the leading bits. So not X, in this case, is going to be 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1. Okay? And we're going to AND that with Z. And Z is 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, and 0, 0, 1, 0. So now we're just looking for everywhere that the ones line up. So we get a 1 here, we get a 1, 1 here, and that's it. And this value here gets stored into Y. So that value here we never actually used. So we never really need to calculate it. Okay, so that's our Y. And then we've got this Z. Now, Z is here. Now, we shift left once and then shift right 2 times. Now, as long as nothing pops off the ends, we can simplify this down to Z shift 1 place. As we talked about yesterday, shifting 1 place to the left is times by 2. Shifting 2 times is times by 4. It's times by 2 squared, which is 4. And then shifting the other way. So we can just, because we know that the shift 1 place doesn't lose any information because we've got this 0 at the end, we can simplify this down to Z shifted 1 place. If this was a 1 at the end, then we'd have to go about it slightly differently because we'd actually lose that bit of information. So we shift Z across 1. Okay, I did that right. Yep, cool. And we OR this with y XOR x. So our x is here and our y is here. So let me just plot y here. 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0. So now all we're looking for is where there is a 1 and a 0, but not both ones. And that's pretty much it. So we get this. Okay. So we have, where's that z? And this is ORed with this. So we get 0, 0, 0, 1, 0, 0, 1, 1, 1. Wait. I'm missing the whole because it's a colleague of leading zeros, which I just left off. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0. So now we're ORing. As long as these are aligned, perfectly fine. So wherever there's a 1 in either of them, it's going to be sure. Now, I need to be careful here because they're not quite aligned. So let's make sure that one matches with that one. So we've got a 0, we've got a 1, we've got a 1, we've got a 1, we've got a 1, we've got a 0, we've got a 1, we've got a 1, we've got a 0, 0, and then the rest of the zeros. So Z now has 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1, 0. Now we need to OR all of these together to get a final result. Now, we can stack these on top of each other perfectly fine, because as long as there's a 1 in any of the rows, they'll all be true. Okay, so that's x. I might actually 3, 2. Oops. And Z is, if I make a mistake, let me know. 0, 0, 1, 1. 0, 1, 7, and then E. And so we're going to OR these twice, but if y is, if one of these are 1s, then the last one's going to be 1. Now we can see that the least significant bit is 0 for all cases. We have a 1 in all of these. We have a 1, we have a 1, we have a 0, 0, 0, 0, 0, 0. Okay. And that gets stored in X. And so we're left with this value. Now we need to convert this back into hex, and you do need to do this. So this is something you do need to know how to do. Okay. So x is going to be 0, 3, 7, 8. So you should be able to convert this number from binary to hex and hex to binary. And you can use your little table if you like. We then need to convert y. So we've got 0, 0, 3, 2. And then we've got 0, 0, we've got 3, we've got 7, and we've got 8. Is that correct? Yes, it is. Cool. Will we asked to convert hexabinary to decimal for large numbers? No, definitely not. Anything to decimal is going to be less than 15. Okay, you won't be expected to convert from decimal to anything large. But binary to hex, it could be a 32-bit number, it could be a 64-bit number, it could be anything. So be aware, your binary to hex and hex to binary, you may need it in a lot of questions. You may need it in only a couple, but you will definitely need it. So definitely, in the several hours to come, make sure that you know that.
What a question.
What's the question?
That was a good question.
And that's worth 2 marks in the exam, so it should take 2 minutes.
I thought it was, to be honest, a 1 mark question, but I don't know. That's fair enough. Should try CS after this extreme. Oh yeah, man. We should live stream CS. That'd be good. We could make analogies of C in CS.
Can I bring my puppy into my exam? That'd be great.
As long as it doesn't know how to program.
Yeah.
Just do it.
I would if I was allowed to.
Yeah. Are there rules against that? Like, I never actually heard of any rules.
I would imagine so. But I don't know.
Like, bro, do I sound that different?
Buddy.
Yeah, buddy.
They all know, buddy.
I'll bring Dakota. She'll just shy away.
Just see the exam and just
Yeah, sure, right.
impressed.
Yeah, pretty much. She was like a typical C student. That was like,
yeah.
been anywhere
I haven't
to do it. Buddy would take it on wholeheartedly. Yeah, damn it! I taught her how to program. Yeah, you only allowed to bring non-programmable dogs.
Non-programmable. It should be on the exam. Actually, that's where they could get you, is that you're not allowed to bring things up with like specific.
Yeah, she's told it to do woofs or barks in a certain in the code that you need.
Is that like the coffee feeding?
Yeah, or you could do like, I don't know. You could put like dots, paint dots on it or something, which is like Morse code for answers.
So I'm going to pull up another question.
Bo, you dog. Because I knew you'd be in it. That's why.
Yeah. Just having a look. We might do one of the. Oh, actually, no. What we might look at, which is the one that one of the persons brought up. If you still want to go over it, errors and warnings. Do we want to go through that? I can generate some errors. I can just bring up Bo's code. It'll have heaps of warnings and errors.
Yeah, ouch. Sorry, I missed it. What were we studying? I have to go. I was doing something else.
Warnings and errors, just random ones.
Yeah. Just show my code, man, dude. I don't think my assignment's recompiled. Just kidding. It did.
So
it did.
It's impossible for us to go through every warning and error. The warning and errors is really about understanding the lecture material and what's legal and what's not legal, and why it may give you a warning and what to do about it. So it is very tied to the lectures, but we can create some examples. So let me
create some standard ones.
This one. So I'm going to do the most simplest one to start with.
Just go through exactly areas.
What?
Yeah, we're going to go through the actual exam in about an hour, so if you want to hang around.
That's what I said. I said I'll go through the exam answers while they're doing the exam. So they can choose to stay here and listen to the answers, or they can go on the exam.
Oh, that'd be so funny. That's harsh.
Yes. Make that bigger. Where's the text? That'll do. All right. So can anyone see what the problem is here? Why is this frozen? Okay. My computer's decided to freeze. How do you know it's an int? How do you know I'm meant to put int there? So don't forget, and this is something that I really need to push, integer types are not just int. Let's do a more difficult example. I think there is actually some in the previous year's exam, which might help. It's a bit annoying.
You can create a type that'd fix it.
Hmm?
You can create a type def called into.
Yeah, this is Bose code.
Yeah, it's just the way I code. I need to have everything spelled out like full length. Like my type for float is floating point number.
Okay, so I'm going to introduce a harder one.
It's just Bose code. Yeah, man, dude, I thought I mentioned this. This is like the 5th time I repeated C. Like I was actually doing it with you guys. Like it seemed like I was helping you, but I was actually there doing it myself. Just the way it goes, you know?
What if I wanted it short?
You'd probably write short, wouldn't you?
Well, yeah, but just because I write int doesn't mean I want an int type, because that's an integer types.
True. P.S. Sad. Figures it all makes sense now. Just you wait, Josh. I'll beat you in a minute.
Yeah, I just pitted him. It's okay.
You just what?
Okay.
Right here.
Hey, mouse is playing.
Yeah. So what you're saying is you don't know that it should be an int.
So it's yeah, so there is no type called integer. So a way to fix this, considering we want an integer type, is to set the type to a valid integer type in C, which could be car, int, short, or long. Okay.
Yeah, that's not the issue.
It's considered a type. And you can see that in the error message. No, it doesn't have to be initialized. A variable doesn't have to be initialized.
No.
So now I've got this one. I'll do the error message as well. This is a warning. Also, unfortunately, I can't make these much bigger. But it says warning assignment makes pointer from integer without a cast.
Mm-hmm.
Ah, I've got a good one. A lot of students did all the bloody time. Even the assignment people do it, but I think they'll pick it up very quickly. So what's the problem? And how would we fix it?
So one was allocating value instead of address. Well, 6 is technically a value. I mean, it is a value. Type is integer.
50 study score per year, yes. So you need more than just a 50 to pass the subject, just so you're aware. You need to pass both the exam and you need to pass it. So there's
A couple ways.
a couple of ways to fix this, and it depends on what you're trying to achieve. So
another way to fix it is to remove y equals 6. Yeah, I mean, that's 100% right, Henry. So, I mean, but it doesn't show the full understanding of what's happening. So, I think the 2 ways Matt is going to talk about is one that you could do what
talk about it while I write this.
What?
Talk about it while I write this.
Talk about it?
Yeah, I'm just putting together another example.
Yeah, so one way which has been said in chat is you could dereference, no, you could, dereference y. So it stores, and so the person with this code is to change the value of what's stored in X. And they could do that by, I'll type it in chat, you could fix it by doing *y equals 6. Yeah, and that would change the value of X. The other thing so you dereference y, which means accessing the memory address of where where y points to. The other thing you can do is maybe potentially you actually wanted to store the memory address 6 in y. So remember, memory addresses are integer values as well. Yeah. If you've got a 64-bit system, then there's 60. The memory addresses within the system store 64-bit. This is memory address 6. We don't know where that memory address is or what it does or what it stores. I mean, but what you could do is to fix it. Another way is to do y equals, and you could do int start, and then you could do 6. So you could typecast the 6 to a pointer. Or yeah. Is that the other way you're thinking of, Matt? Typecasting it to a pointer?
I wouldn't. That was mentioned, and you can do that.
It doesn't make much sense. The other way,
it does make sense in some systems, but for you guys, it's really irrelevant. You're not at that level. You you actually know where things are in memory.
Yeah.
And it's very unlikely on an operating system you're going to know. Generally, you'll only know when you don't have an operating system.
Yeah, like, I mean, the second way will fix it, but it's probably not the right way. X equals 6. What was that code as? So, or int y equals x. Yeah, no, because I think the issue with this is happening on the line where we do y equals 6. So when you guys are giving your answer, I would only be wanting you to say how to fix that particular line. I don't think there's going to be a question where it requires you to fix lines before the warning or the error. I'm not 100% sure on that, but I'm pretty sure that that'll be the way it will be. Because I mean, you could, like, to fix this, you could just remove everything, right? That would, well, everything within main, and that would technically fix it. But that's not what we're after. We're after, like, explaining how you'd fix the actual particular warning in a way that makes sense.
So I've got a bit of code here. It has a bunch of errors and crap. Just add a couple of things.
Yeah, that's correct, Emma. Dereferencing Y with the best way. Yep. Yeah, I'd say it's the most. Big boy. Others fine. Yeah. I mean,
There you go, remember that was good.
Answer's good. Yeah. Hey, well, that's his name, man. I don't pick the shots around here, right?
Yeah. That would be kind of funny if that was a student's name on LMS.
Big boy.